Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning. I would like to thank you all for attending today's webinar, which is titled under Emirates Mars Mission Science Overview. We are honored to have Her Excellency Sarah Al Amiri, the Minister of State for Advanced Sciences, the Emirates Mars Mission Science Lead, and the Emirates Mars Mission's Deputy Project Manager. So before we start with today's agenda, we'd like to share with you a short video on the Emirates Mars Mission. Thank you all again for joining us today. So today's topic will be in the Emirates Mars Mission Science Overview. This webinar will be 3 hours long. Now we'll introduce Engineer Fahad Al-Mihiri, the Executive Director of the UAE Space Sector and the Chairman for the Emirates Space Innovation Group, to give us the opening remarks.
Assalamu alaikum, distinguished guests, ladies and gentlemen. Welcome to today's session on EMM Science. My name is Fahad Al-Mihiri. I'm the Acting Executive Director of the Space Sector at the UAE Space Agency. And I'm thrilled to be with you all here today for another exciting webinar. It is our honor to host Her Excellency Sarah Al Amiri with us here today, and of course her EMM Science team. And we also have a list of presenters from NSSTC, NYU Abu Dhabi, and Zayed University. I would like to quickly familiarize you all with the platform you have in front of you. Please use the chat for general discussions. All our panelists are welcome, of course, to participate. As attendees, if you have any questions you would like to pose, please don't ask them in the chat. Use the Q&A box instead. Now, depending on the time we have, some of them we may be able to answer live, but if not, we will surely get back to you and throughout the session, and the team will definitely be very active and going through those questions and answering them. The EMM team also have some of our lead scientists available in the background other than the speakers, who are going to be available to answer even some of the technical questions you may have today. Now, when the father of the nation, His Highness Sheikh Zayed Al Nahyan, may his soul rest in peace, united the Emirates, he had a clear vision. And since then, we have been translating this vision into a reality. In less than 50 years, the UAE positioned itself at the forefront of major sectors globally, now including space. Last September, Hazza al-Mansouri marked a historical and monumental feat for the country and the region as the first Emirati astronaut and the first Arab on board the International Space Station. Now we are less than 30 days away to achieve yet another milestone for the UAE and the Arab world, the launch of the Emirates Mars mission on July 15th, expected to enter Mars orbit in 2021, coinciding with the Golden Jubilee of the Union. The EMM will be the first probe to provide a complete picture of the Martian atmosphere, to give scientists a deeper insight into the past and future of our planet, as well as the potential for life for humans on Mars. Driven by the passion of the UAE's wise leadership, the EMM is a real step forward in Mars exploration towards the Mars 2117 project, which represents a major contribution to humanity's interplanetary endeavors. The Emirates Mars mission will leave behind an important legacy on Earth as the first mission being planned and managed in the UAE by a 100% Emirati team. It is a catalyst for a new generation of Arab scientists and engineers, and an anchor project for the growing science and space sectors. To support this growth, our focus is centered around the youth, whose capabilities will pave the road for innovation in this thriving sector. Our wise leadership has been committed to empowering our youth and in unleashing their full potential. Supporting scientific research and local talents aids us in building the next generation of space sector innovators and scientists. Their space innovations will pave the way to position the UAE as a leader in space sciences and an exporter of space solutions. At the UAE Space Agency, we are committed to supporting the growth of the global space sector and engaging with international partners to exchange knowledge and expertise. We are delighted to share our experience of developing a national space program with international experts and decision makers. The UAE has become a regional center for space, with the UAE Space Agency mandated to cover regulations, support the human resource development in the field of space, encourage R&D in it, and of course, build partnerships through international cooperation, and of course, the Mars mission with Mohammed bin Rashid Space Center, having proudly been delivering this project with the EMM team. We today have over 22 billion dirhams invested in the space economy, 10 satellites in orbit today and 8 currently being built, 5 R&D centers and 3 universities offering space programs. We have over 3,000 employees in the space sector, almost 20% being women. MBRC's astronaut program hope to see one of those women in space in the near future, inshallah. Next slide, please, Abdullah. As His Highness Sheikh Mohammed bin Rashid Al Maktoum mentioned, the Emirates Mars mission will be a great contribution to human knowledge, a milestone for the Arab civilization, and a real investment for future generations. The Emirates Mars mission will be a project that will be recorded in history. As you see in the timeline, this mission started in 2014. We are now past the halfway mark, where the Mars Hope probe today, sitting at the launch site in Japan, with 14 UAE nationals, part of the EMM team who have been by the probe side since April, ready and fueled for MHI to release the probe to its path to Mars. This reiterates the UAE's belief that the sky does not define our limits, as when it comes to space, the sky is only the beginning. Thank you, Anna. Sorry, Abdullah. I believe Her Excellency will be going through this. So we will continue, and I'd like to introduce Her Excellency Sarah Al Amiri. It's a great honor to have you here with us today.
Thank you, Fahad, and it's a pleasure being here. Good morning to everyone, and thank you for participating in this session today. I will go ahead and share the screen and start with the EMM's overview. Right. So today I'll be talking about the overview of the science mission of the Emirates Mars mission, the general journey to Mars that we'll be taking, and also where we've started and where it's gone forward from. Just a reminder on the project objectives. This project, we started working on it in late 2013 when the feasibility and the idea of going to Mars was started from the Prime Minister, Sheikh Mohammed bin Rashid Al Maktoum. And we were given 3 basic objectives to design and develop this program for. 1, to continue developing our science and engineering capabilities at the Mohammed bin Rashid Space Center and the wider space community, and to increase the complexity of the capabilities of the engineers and start developing and designing a mission where scientists and engineers work in conjunction to develop this program. The second objective is that the science of this mission needs to be novel in nature, as in it answers and addresses objectives that no other mission is currently designed and built for, but it's one that is complementary to other missions because scientists need to benefit from the data from this mission. And the third is arriving at Mars by the 50th anniversary of the formation of the United Arab Emirates in December 2nd, 2021, which gave us the opportunity to launch in July of 2020. EMM partnerships is quite complex on this mission. This mission was designed and developed through a know-how transfer program with strong knowledge partnership from last together with the MBRC. Science team is quite diverse science team from scientists from various backgrounds and the foremost scientists in planetary atmosphere and especially Mars atmosphere who are members of the science team of this mission in conjunction with the Emirati team who are resident at MBRC in the UAE Space Agency. The instruments were jointly developed with the Laboratory for Atmospheric and Space Physics at the University of Colorado Boulder and Arizona State University with input from the Space Science Lab at UC Berkeley. We also see here that the launch vehicle, which is going up in July 15th, inshallah, is developed by Mitsubishi Heavy Industries, and that launch vehicle is currently in preparation at the launch site today. Where we've come from that first meeting, late 2013, with very basic knowledge of planetary exploration to where we've come today as an overall team, has been a remarkably challenging journey, and one that we see the culmination of it at the launch site this July. The launch, of course, is a first step in a series of challenging steps that gets us towards our destination. We begin our cruise in July. Right after we launch, roughly 15 minutes after we launch, our spacecraft needs to stabilize itself. The solar panels need to open, and we need to get the first signal from the telecommunication system on board the spacecraft to ensure that the basic systems, our energy, our communications are functioning and are doing well. That is at that point where the first command is going to go to start directing, for the propulsion system to go on and start directing our first maneuver towards Mars for the start of the trajectory. Once we start that maneuver, we start a 7-month-long journey towards Mars, where there are also scheduled checks for the instruments, scheduled checks for the spacecraft itself to ensure health and safety of the overall spacecraft. And more importantly, there will be several other trajectory maneuvers so that we are prepared to arrive at Mars in February of 2021. At arrival, that is our second most critical point in this mission after launch. At arrival, we need to slow down the spacecraft and utilize the propulsion system to brake the spacecraft's speed, and that propulsion system needs to turn on for 30 minutes continuously. At the point of Mars orbit insertion, we have no real-time communication with the spacecraft due to communication delay. And therefore the team has rehearsed time and time again that overall maneuver to ensure that the spacecraft can respond to any possible anomaly that could happen during that process. Once we enter into Mars, we don't go directly into our science orbit that I'll be talking about earlier on. We actually go into a capture orbit that's at 1,000 kilometers at its closest point to Mars and 49,380 kilometers at its furthest point in Mars. In this capture orbit, we ensure that, again, the spacecraft is functioning and everything that's within the spacecraft is functioning and stable. And more importantly, we do our first observations using our 3 science instruments to check that the data that we're receiving from the instruments are data from Mars itself rather than artifacts of the instruments and the data being captured by the instrument. It will take roughly 2 months to be in this orbit according to the needs that is found from the health of the overall spacecraft. We will then transition to our science orbit, which is a 20,000 kilometer by 43,000 kilometer orbit, which is a quite unique orbit around Mars, and the purpose of that is to serve for our science objectives. We start our science operations sometime in late April, beginning of May. Those dates that you'll see here are relative dates, again, to when we're going to launch, and more importantly, when we're going to arrive. Once we get into our science orbit, that's when science data is captured. And we continue in this orbit for an entire Martian year. So our primary science mission is meant to finish around March of 2023, where we will finalize the analysis of the overall mission. The spacecraft is actually designed to work for roughly 2 Mars years around Mars, and there is a chance for an extended science mission that we hope is going to be led and addressed by the UAE science community to further understand and learn and maximize the benefit from this mission. You'll see here several, again, information pieces about when we arrive and how we're doing communications, but more importantly, when we arrive at Mars is at the new year of Mars. And we start our study of Mars during the spring Northern Hemisphere season of Mars and continue on till the next spring of the following Martian year. The science objectives of the mission have been derived from 3 primary science questions. This mission is meant to fill a major gap in our diurnal or day-to-night understanding of the Martian weather dynamics in the lower atmosphere, and provide for the first time a correlation between the weather system on Mars and reasons for atmospheric loss, and specifically focusing on hydrogen and oxygen loss from the upper atmosphere. So to do that, we also need to capture measurements on the upper atmosphere and the thermosphere and the exosphere of Mars to be able to correlate the data sets that are being collected by both the lower atmosphere understanding and the upper atmosphere understanding of the planet. This is the Emirates Mars Mission Science film, probably the easiest way that I can explain this. The 3 objectives that have been set for this project flow down to 4 science investigations. The investigations is where we start our design of the overall mission and the spacecraft and all the subsystems that go from it. And this is what dictates what we've been designing for over the past 6 years and what we measure against on whether and validates our spacecraft and the instruments against. And that has been ongoing over the past year. The first science investigation determines our 3-dimensional thermal state of our lower atmosphere. And again, all time scales, so every data set that we capture needs to have diurnal variability. We need to cover all seasons of Mars, so there's a subseasonal timescale requirement there, and an entire Martian year, which is intrinsic to the amount of time that we're going to operate the spacecraft around Mars for primary science. For the first investigation, we require both the temperature profiles of the atmosphere itself and also the surface temperature, because we need to extract that out of the atmospheric temperature. And we use the carbon dioxide, the most abundant element on Mars, to be able to get that temperature. And that's also mapped to our thermal spectrometer. The team is going to talk about each of the instruments, so I won't go into the details of the instruments, but these are the driving requirements that the instruments have been designed for. The second investigation is understanding the distribution of key constituents in our lower atmosphere. And by key constituents, this is what we're studying. So we're taking, again, surface temperature. We want to better understand the water vapor circulation throughout an entire year. So that's the second focus area. Dust, again, primary constituent of the lower atmosphere, and dust storms is very important to further investigate and understand. And we rely on the EMIRS instrument to get the dust column optical depth. We also study the ice column and also ozone, which is a tracer element that allows us to better understand the mission. Better understand the distribution of other key constituents within the lower atmosphere. For our third science investigation, this is our binding, sort of the link between our lower atmospheric measurements that are driven by EMIRS, our infrared spectrometer, and EXI, which is our imager, but has a few UV bands in it, and correlates that with our upper atmospheric measurements. So this is the link between what happens in the lower atmosphere and the atmospheric escape in the exosphere. And for that, we focus on carbon monoxide and oxygen in the thermosphere to be able to do that correlation. And this brings us to our last investigation, which is understanding the extension of the hydrogen and oxygen corona into space. And this gives us the atmospheric loss factor of this mission. And we look at both the light intensity of hydrogen and also the altitude profiles of hydrogen all the way out. And again, in the instruments presentation, you'll see how the measurements are happening for the corona and how far out from Mars' disk do we go. The placement of our 3 instruments are all placed on what we call the instrument plate. The reason, and this is shown here in this 3D rendering of the spacecraft. The reason for that is we need simultaneous measurements from all of these three instruments to be, or pseudo-simultaneous measurements from all these three instruments to be able to correlate the data sets. More importantly, because EMIRS and EXI both work in conjunction, we require those observation to be quote unquote sandwiched between each other during our observation cycle to ensure that we get, again, pseudo simultaneous data sets from these two and be able to get a full picture of the lower atmosphere. The orbit of Mars, like I said, of the HOPE probe, as I said, is a unique orbit. At its closest point, it's 20,000 kilometers. At its furthest point, we're at 43,000 kilometers. It takes us 55 hours. It takes us 55 hours to orbit Mars once, and that's a purposeful, and explain why we need a 55-hour orbit to orbit Mars once. The way we observe the spacecraft, this is how we get our both diurnal coverage and be able to cover the surface of Mars completely. So at our periapsis, our closest point to Mars, we are able to observe Mars as if we are a geostationary satellite. So same location in Mars, multiple lighting conditions during different times of day. The further we get away from Mars, the more we're able to observe different locations at different times. And throughout a 10-day period, we're able to observe all locations on Mars at all local times. And that provides us the full understanding of Mars every relatively 9 sols. And hence the reason for the period being 55 hours, which is 2.25 sols, is because of the rotation of Mars allows us to observe the entire location, the entire surface of Mars. Now to get a bit, because the poles of Mars are quite interesting, so to get a bit of the poles, the inclination of this orbit is 25 degrees. Here are a few quote unquote images from Mars, and shows you the observation that you're going to get from Mars and how you can see Mars. This is from EXI, our imager, but it's roughly the same face that all 3 instruments are going to see. I've arranged those as distance, so as altitude from Mars rather than at time, so you'll see lighting conditions that are not really in chronological order. So this is at our closest point, 20,000 kilometers. This is getting further away from Mars and further again away from Mars. And Mars starts getting smaller as we get further away. This shows the different lighting conditions that we're getting at our closest points of roughly the same area of Mars. Now the ground segment, and maybe the part that's the most important to everyone here, is how do you access the data? And that falls within the ground segment of this mission. The Science Data Center is the primary brain that processes all science data all the way up to level 2 science data products. And this is also where you can access what we're calling level 3 data products, which are more usable science products. The Science Data Center as a whole is accessible by the science team. The reason for that, there's a lot of background processing that goes on in the Science Data Center. The public version of the Science Data Center is called the Emirates Space Data Center, and that is publicly available for anyone to access and download the science data that they require to conduct their research. Research. There's full information on the data processing and the science levels that are going to be available on the Emirates Space Data Center. We are also working towards enhancing it by adding more and more tools, and you'll see some of the tools for visualization that have been developed internally in conjunction with other teams. This is the data release policy as it currently stands. The science team gets no initial embargo period of using the data before anybody from the science community gets to use it. What happens is that the science team, especially initially, and that's why we have an August 2021 initial launch release of our data to the public. And the reason for that is to ensure that the data that's being collected is data of Mars and not data that are artifacts of the instruments themselves. So we need to ensure that the data pipeline and the data processing mechanism is all correct, that the observations that are coming in from the instruments, again, are all correct and checked and verified time and time again before we release data to the public. Level 2 data products will be released to the public, and we can give you more information on what we mean by that. And then we release data every 3 months at a regular cadence. We will review the release policy once we start getting the data. If we need to release it earlier, we will start speeding up the rate of release, and that's all dependent on the overall mission itself. So with that, this is all I have with regards to an overview. The team's going to go into a deep dive on each of the areas of the mission itself. But if you have any questions, I'm not sure how you're handling Q&A, but if you have any questions, I'm more than happy to answer them.
Your Excellency, thank you so much for that detailed insight. I think it's been great. I think a lot of people have learned a lot today about this. We have already been receiving a lot of questions, and the team, mashallah alayhim, have really been getting back at a lot of these questions already. But I think a lot of people are really interested in terms of the data and how that is distributed. I think you mentioned it clearly now. So I think to all, it is important that you understand what that means, level 2 data. And to the entrepreneurs out there, I would look at this as an opportunity. You know, when we talk about the GSIA and the opportunities that this could present, value add service on top of this data could go a long way, as this is all new data expected from the probe. Your Excellency, thank you so much for your time, and really thank you for everything that you know, you have done towards science, towards the women of the UAE. I think you've been a fantastic and a great inspiration to us all. We see a lot of comments here in the chats, and I'm sure you'll be able to get on and take a look at that. I know that you will unfortunately have to leave us at the end of the hour, so I'd like to just take this time to again thank you very much, Your Excellency.
Thank you, everyone, for giving us this opportunity to talk to you towards the mission. And this is definitely not going to be the first time that we meet with everyone. The more we get understanding of the data of the mission, we will have another session here. And something that I want to highlight, because I won't be able to stay all the way across, and I apologize for that, but something came up in the last minute. Something that I want to stress, that if you want to use research using the EMM science data, by all means, you don't need to be part of the science team. Whatever data that you require, whatever information that's required, tools and so on, the team is more than happy to provide for. The science team is working towards the science objectives that I spoke about. But these are not the only science objectives or opportunities for research that you can get out of this mission. And there's a lot of opportunistic science that can come out of it. But the focus is, and trust me, the scientists on the team have been wanting to go on those tangents for so long. So you can find even partners to start working with on them. But our focus as a mission is to meet our objectives, because we've declared objectives, and by the end of this mission, we need to address those science objectives. And this is how we declare mission success. And therefore, we can't deviate from the mission objectives. And we would love to see more and more universities and research groups within the UAE to start using this data and use tangential scientific research questions and start addressing those, because the data can be used in multiple ways. And again, I reiterate that the team is committed to provide support in any way possible. Again, thank you all for your time.
Thank you, Your Excellency.
Thank you.
I think, go ahead, yes, Abdullah.
Thank you, Your Excellency. Now we'll move on to the agenda. We'd like to ask everyone, please, to ask questions in the Q&A box, not in the chat, so that's better for the panelists to answer. So now on the agenda, we have Mariam Shamsi from the Mohammed Barashid Space Center to give us an overview of the HOPE probe instruments.
Yes, thank you, Abdullah. Just give me a moment to share screen. Okay, Assalamu alaikum. Good morning, everyone. Today I'm going to be presenting about HOPE's probe instruments, as well as the scientific data that we'll be capturing. My name is Mary Al-Shamsi. I'm the MBRC Instrument Science Lead for the mission. So you will see in today's presentation, I'll be going through the instruments. As Her Excellency mentioned, we have 3 instruments on board HOPE probe, EMIRS, EXI, and EMUS. And then I will be going through the different data sets that it will be capturing and what are the scientific targets that we are interested when we study the lower and upper atmosphere of Mars. So these are the scientific questions and the science flow down actually that Her Excellency mentioned. I'm going to be focusing on the investigations, as you can see the yellow bubbles here, and then a flow down into and diving into different specification of the instruments we have. So starting first with the first 2 investigations, which focuses on the lower atmosphere. The first investigation focuses on getting a thermal state of the lower atmosphere in all times of day and season, as well as covering the whole geographic location of Mars. And then the second investigation focuses on getting and studying key constituents from the lower atmosphere that will give us a better understanding of the lower atmospheric dynamics of Mars. And this will be captured using EMIRS for the first investigation and partially for the second investigation. Now, EMIRS, which is Emirates Mars Infrared Spectrometer, it's a project or a pilot jointly developed by Arizona State University as well as Mohammed bin Rashid Space Center. EMIRS has a high heritage from TESS instrument. TESS flew into Mars Global Surveyor, and we usually use the data set from TESS to depict the same data sets that we will have from EMIRS as well. EMIRS will have a better resolution in data sets from its predecessor TESS. And when we talk about the observation that we will get, as Her Excellency mentioned, we will be having a 55-hour orbit. So in one orbit, we will be capturing from EMIRS 20 observations. This totals into 60 observations per week. When it comes to resolution, we're talking about better than 300-kilometer resolution with the spectral range from 6 to 40 micrometers. Now, as you can see from this presentation on the left, we have the CAD model image of EMIRS instrument, and on the right is the flight structure image of EMIRS that is already assembled on the spacecraft. So EMIRS it has a scan mirror capability, so it will be having 2 observation strategies. Maybe if you can see this picture on the right, it will be easier to explain. So EMIRS, when it gets its observation, it utilizes the spacecraft slew. So as the spacecraft slews on the surface or the surface of Mars, EMIRS is going to be using its scan mirror imaging to cover the locations that we need, or to cover the whole surface of Mars. When it comes to the duration of the observation, we're talking about if it's periapsis, which is the closest orbit location that we can capture data from, it's around 30 minutes. And when we're talking about the furthest place, which is apoapsis, it's around 11 minutes to complete an observation. Now, this is another picture that shows how the observation is taking place. So this is using observation, the first observation, and this is using the second observation of EMIRS. As you can see, the first observation is going to be capturing the data sets or the whole data set that we need, but you can see a bit of gaps. That is where the observation, the second one, comes in. The second observation will have a lower resolution, but it will be sufficient enough to get the whole observation that is needed from EMIRS. Now, when we talk about the scientific products that we will get from our infrared spectrometer, we are going to be measuring the dust optical depth at 9 micrometer, water ice optical depth at 12 micrometers, water vapor column abundance, temperature profile attitude from 0 to 50 kilometers to characterize the lower atmosphere. And then we're also going to be measuring the surface temperature at the 1,300 centimeter inverse. And this is all to get a better characteristics and understanding for example, dust, water ice clouds, the water cycle and how the dynamics change in the lower atmosphere, thermal state of the lower atmosphere, and also getting a surface temperature in order to understand the radiation that's coming from the surface of Mars. Now, moving to the second investigation, as I mentioned, it's partially satisfied by EMIRS by measuring the dust column, optical depth, the water, and the water ice clouds. So this, as Her Excellency mentioned, is going to be in conjunction with EXI, which I'm going to be talking about in a bit. So EXI is a joint collaboration between Laboratory for Atmospheric Space Physics in CU Boulder, as well as Mohammed Barraj Space Center. It's a multi-band imager. It has a capability of taking 12 megapixel images, and resolution, when we're talking about, it's better than 10 kilometers. And I would like to also mention it has a filter wheel mechanism. So we have 3 near UV bands as well as the RGB bands. So as you can see on the left, this is a CAD model of the image. Maybe you can see from this image better that we have 2 baffles or 2 channels. We have the UV channel and we have the visible channel. And then it has this shape because of the filter wheel mechanism that it's going to be using to capture different data targets. And then this is also the flight structure that was already assembled on the spacecraft. Now, the science products that EXI is going to be capturing, we have first the water ice cloud column integrated optical depth. This will be in conjunction or correlating with EMIRS data sets to get a better characterization of the water ice clouds. And we'll be capturing this in the 320 nanometer. When it comes to ozone, we are also going to be measuring ozone so that we get an understanding of the water tracer. It's a good water tracer in the lower atmosphere. So we are going to be measuring that in terms of column integrated abundance in the 260 nanometers. And we're also going to be capturing beautiful images of Mars using the RGB bands. This is all, as I mentioned before, better than 10 kilometer resolution. Now, when it comes to the observation, we have 2 science observation for EXI and 1 PR. So the PR is using the RGB to get a full resolution image of Mars. And then we do have 2 scientific observation. Maybe this picture will show it better. The first observation will be using the UV bands to get a scientific product that we need. And then, as I mentioned before, EMIRS observation is going to be taking almost, if we're talking about periapsis, around 30 minutes. So we do get another observation from EXI, which we consider as a bookend observation, so that we make sure that we're covering the whole surface of Mars and there is no missing data during that time to complete the data set. So we'll be having a lower resolution, but it will be sufficient to cover, for example, if we're missing the edges and any gaps that we need. Now we focus on the 3rd and the 4th investigation, which focus on the upper atmosphere. Now, the 3rd investigation focuses on the lower bound of the atmosphere, the upper atmosphere, which we call it thermosphere. We will be studying the neutral species of that. And it's also an investigation to correlate whatever is happening in the lower atmosphere. For example, if we have dust storms or any events that are happening, it is going to be correlating that and connecting that to what is happening in the exosphere, which is the 4th investigation. which we're going to be studying the hydrogen and oxygen, which is the building blocks of water, and how they're escaping the planet. These observations or investigations will be satisfied using EMUS, which is our ultraviolet spectrometer. So EMUS is the Mars ultraviolet spectrometer. As I mentioned, it's a far ultraviolet imaging spectrograph, and it will be measuring hydrogen, oxygen, and also the thermosphere when we're talking about oxygen and carbon monoxide. So when we're talking about thermosphere, we're talking about altitude from 100 to 200 kilometers. And the exosphere is above 200 kilometers. On the right, you can see Emirates. As you can see here, this is where the observation takes place. And I'm going to be showing a better image when it comes to the different components of EMUS instrument. The wavelength of EMUS is from 100 to 170 nanometer and having a better than 300 kilometer resolution. We do have different slit positions, so we are going to be having different resolution for EMUS. We have 1 nanometer at 1.8 nanometer and 5 nanometer spectral resolution. So EMUS is also a joint collaboration between Mohammed bin Rashid Space Center and LASP. I would also like to mention that the detector is going to be developed by our partners in SSL UC Berkeley. So this is an engineering model image of EMUS. This is the where the light comes in and where the observation is. And as you can see, we have the different components that make up this instrument. Now, when it comes to the scientific targets of EMUS, we can divide it into 4 regions. So the first region is from 0 to 1.06 Mars radii, which is the thermosphere. So when we talk about Mars radii, it's actually the distance from the radius of Mars to the altitude that we would like to measure on. So the targets of that is we're going to be measuring the hydrogen, more importantly, the oxygen and carbon monoxide when we're talking about thermosphere, in Lyman alpha and Lyman beta. And also we're talking about dim and bright oxygen, and when we're talking about carbon monoxide, we're talking about the 140 to 170 nanometer range. This is going to be used using the 1.3 nanometer spectral resolution. I'll be talking about the observation in the next slide. So in region 2, which we're focusing on this area, it's from 1.06 to 1.6 Mars radii, and this is the first bound of the exosphere, the beginning of the exosphere. So we are going to be capturing the hydrogen corona and the thermal oxygen corona and these wavelengths, as I mentioned, Lyman alpha and Lyman beta, and also bright and dim oxygen. This will be used using the 1.8 nanometer spectral resolution. Now, when we're talking about the third region, it's from this area to this area over here, 1.6 to 6 Mars radii, measuring the hydrogen corona and the bound oxygen corona. We're measuring it in Lyman alpha and Lyman beta as well, and dim and bright oxygen. When we're talking about the fourth region, which is the end of the exosphere that we would like to measure, it's from 6 to 10 Mars radii. We're focusing on the hydrogen corona and also escaping oxygen elements. And this is going to be done using Lyman alpha and bright oxygen, using the spectral resolution of 5 nanometer. Now I'm going to be going through the observations for EMUS. We have 4 scientific observations. The first one focuses on the thermosphere, and we're going to be capturing a raster scan image of that, capturing the oxygen and carbon monoxide. This will be done at least twice per orbit. Now, when we're talking about the corona, which is partly studying the exosphere, we're going to be measuring it, as you can see here, on different locations in the orbit, basically scanning different orbit location to get the better data set when it comes to oxygen and hydrogen corona. As you know, the corona, we need to go further away. We will get more information to cover that. This will be done at least 6 in 1 orbit per week. Now, this is the third observation. It's mostly done to take away or remove any background noise or anything that will give us a better understanding of the corona and better measurement of that. So it'll be done in an asterisk pattern. And then when we talk about the strafing, this is done once per month, and it's basically getting a more photon count for oxygen to get more exposure time. And this is usually done when the spacecraft is not doing an observation, but it's maybe charging. So we are going to be doing that to get more accurate data. Now moving on to the science data chain, and you will hear scientists refer to that as either data chain or data pipeline. And it's basically talking about the path of data from one point to the next. So as most of you already know, that when we take an observation, we take it in terms of brightnesses from the reflectance of the sun. And usually when we transmit data back to ground, it's done using, so we take the brightness to digital numbers and we transmit that through digital numbers. And when it comes to the pipeline, and the pipeline is responsible for converting back the digital number into the brightnesses. We take these brightnesses and we have models to convert data into the physical parameters that we need. It converts it to the densities that makes it readable for the scientists to do their analysis and observations. And from the physical parameter, we either take it to data analysis. We do data analysis basically, which focuses on answering our science questions, or we usually sometimes also take the data to change it into a different visual image or different visual readings, such as mapping and so on, in order to later also analyze it in a different way. So I'll be focusing a bit on the pipeline and the path for that. So when we talk about the pipeline, we talk about different levels of data. And when we mention different levels of data, we mean that different maturity of data. So let's take an example. This is an example for EXI data set.
Miriam, sorry,
Yes.
just to be wary about time, please.
Okay, sure.
Okay.
So it'll be fast. Thank you for letting me know. So when we take the data set, we go to level 0, and level 0 is usually the raw data, housekeeping data, and so on. So we convert it into a FITS image. A FITS image is an image that is usually used by scientists to get a flexible image data set. So it goes into an uncalibrated, and then when you go to level 2 using radiometric calibration, we calibrate the data. And then when we go to level 3, it's a full physical parameter that you can do also studies and analysis on. So usually we will be sharing level 2 onwards for EMM. So I'm not going to go through this in detail. EXI has Hubble Space Telescope has a similar geometry to EXI. So we usually use data sets that are similar to our instrument before we get the real data, and also simulated images. EMIRS will also have FITS format. And as you know, as I mentioned, level 2 onwards will be calibrated and the physical parameters for EMIRS. This is a similar data set that we will capture for EMIRS using tests. And for EMUS as well, physical FITS format, and we will be measuring and sharing level 2 onwards for that. This is an example of a data set from EMUS. This is from the detector. We take it to the brightnesses. We either take column density and the hydrogen oxygen corona, and usually you will see the data set similar to this. And this is the brightness for 130.5 on Mars. So thank you, everyone, and please feel free to put your questions in the Q&A.
Yes, thank you very much. So in order to save time, thank you very much, Miriam. That was really insightful. I think a lot of people are asking, are you going to be able to make this presentation available?
Yes, actually, the presentation that was shared also has more details. So
Excellent.
It'll be great to use that.
Excellent. So to all of those asking, you will be able to have access to this, inshallah. I know a lot of you have classes that you're jumping into and you're kind of jumping in between, so we'll make sure to do that. Thank you very much, Miriam. And to everybody, please continue sending your questions across, and I'm sure Miriam will be more than obliged to be able to answer them through the question and answer box. Next up, we have Mohammed Al-Falasi, also from the Mohammed bin Rashid Space Center.
Thank you, Fahad. Assalamu alaikum. Good morning, everyone. Please wait a moment until I share my screen. Could you all see my screen?
Yes, we see it.
Okay.
Thank you.
Thank you. So first, I'm going to introduce myself. My name is Mohammed Al-Flasi. I work as an engineer in the science data section within the space science department at Mohammed bin Rashid Space Center. So today, I'm going to talk about the Science Data Center, explain briefly what it's about, and I will be giving a walkthrough on how to access the data of the Emirates Mars Mission HOPE probe. So this will be my outline. First, I'm going to talk about the Science Data Center and its data flow. I'm going to talk about the SDC, SDC website. Then I'm going to move to data distribution, release policies, and explaining how can someone access the data on the HOPE probe. So first of all, in the Science Data Center, we're mainly focused on processing, managing, and distributing the data of the Emirates Mars Mission HOPE probe. As you know, the data from the HOPE probe comes at a huge volume that will require managing of the data, such as processing, storing, and distributing the data. First, in the Science Data Center, we will process, generate the level 1, level 2, and Outlook science data products on a regular and automated basis. The processing software is developed by the ITFs, or the instrument team facilities. This processing software is used to process data from a lower level to a higher level. Moving on, I'll talk about the data management. So in the Science Data Center, we receive and manage level 0 data and other types of data that comes from the MOC, which is the Mission Operations Center. We also receive and manage level 3 data, which comes from the ITFs. Also, we provide the ITFs with access to all the data that's available on the SDC, science, and other types of data. And we also maintain a secure and stable repository of all data that will be available throughout the mission. And we will also establish a long-term archive, which will be used for Emirates Mars Mission and future missions also. As for data publications, we have we will distribute the science data products on the EMM science team website, which is for the scientists. And as for the public, we have the Emirates Space Data Center, which will provide accessible mission archive of all the products and processing software and data and different type of analysis tools that will be available. So moving on to my next topic, I'll talk about the science data flow within the Science Data Center. So first we get the telemetry from the spacecraft of the 3 instruments. It goes through the ground network. After it goes through the ground network, the data goes to the Mission Operations Center, which is located at MBRSC. We receive the level 0 data. This level 0 data is processed to a higher level data, such as level 1, and then to level 2 data. As for level 3, this will be generated by the ITFs. And all this data will be managed and stored within the SDC. The Emirates, as I said previously, the Emirates Space Data Center is the public version of the Science Data Center, which will allow the science community to have access to our Science Data Center. As for the EMM Science team, they have access to the data of the Science Data Center, and they also develop tools for the level 3 algorithms to be able to generate the level 3 data from the ITFs and store it on the SDC. So I'll move to the next topic, which is the EMM SDC website. The EMM SDC website, or also called the Emirates Space Data Center, will be your main source for all the science data that will be generated throughout the whole mission, which is from the 3 instruments which are from the whole probe. It is integrated with the SDC's backend system, so all the data that would be stored on the SDC will also be available through the website. Moving to my next topic, which is the data distribution. The EMM science team, which is the core science team working on EMM, will have access to all the science data products, which are level 0 up to level 3. And even before the data gets released, they have access to the data. They will work to verify that the data isn't corrupted and it works correctly for the public. As for the science community, they will have timely access to useful products, the level 2 and above data, which will be released. Only the released data will be available through the Emirates Space Data Center. As for level 0 and level 1 data, it will be placed in the ASDC archive during the end of the mission at the decommissioning phase of the Science Data Center. There are tools that will be available on the ESDC website, such as data analysis, access, and visualization tools for the EMM at the EMM SDC website. It is expected that science data will be released 4 months after receiving the data. It will first be processed initially using what's called a predicted ephemeris. Then it will be reprocessed and re-released using reconstructed ephemeris. Ephemeris data is a file that describes the location of the spacecraft in space. Also, any updates or changes to the processing algorithm will result in releasing the data. So any updates on the algorithm, the data will be re-released again. Users on the EMM SDC website that are registered can receive email notifications once new data is released on the website. So now moving forward to my next topic, which is about the expected data release schedule. This might change in the future, but for now, what are we expecting is that, as you can see here, the first data set, which is for the month from February to April of 2021, it will be released almost 4 months after we receive the whole data, which is during this time. So it will be processed and to level 1, then to level 2 data. At this point, it will be publicly available. So we have also the second data set, which is from May to July. It will be released during the November-December timeline. The level 2 data will be released. In addition, we will also release at the same time the level 3 data that will be available at the same time, and so on and so forth until the end of the mission. So moving to my next topic, which is the data release policies. All of the EMM, the science data, will be released to the public for the benefit of the world science community. The ITFs and the EMM science team will have access to all levels of primarily science data and all the tools that will be available, while the science community will have access to the level 2 and level 3 science data products. Other types of data, such as spacecraft and instrument suite housekeeping, engineering data, it will be provided based on a designated individuals or organizations on restricted basis as approved by mission management. So now I'll talk about the EMM website. So within the website, you can register an account for free. It will be a simple and straightforward process to register an account. You will need also to verify your email. And then you will need to provide some info to make the account be activated. So moving forward, on the website, the user will need to enter specific parameters such as the type of instrument and the date range, like the starting date and the end date of the science data. And the user can also specify if he wants to access the latest version of the data or all the versions that are available. Also, the user can specify the data level as well. So as you can see, this is a screenshot of the website. So I'm going to show the website in a moment after I finish my presentation. So as you can see, after filtering or putting in the parameters for the instrument data, we can see the data available for within the table here. So this table, it shows this data is from which instrument and from which data level and which time and other information. So the user can select which data he wants to download. Then the user will need to click on download. After the user clicks on download, he will receive an email that contains the download link for the data that the user selected. It will be compressed and sent to the email. Once the user downloads the data, he can start working on the science data. So moving on, we will have visualization tools available on the SDC website, which can provide different visual view of the data, such as plots and graphs. One of the tools will be the quick look plot. It will be available for each of the instruments on the EMM SDC website. And the user can specify also the time range for the data to see different data in the website. So I'll stop sharing for a moment and I'm going to show you the EMM SDC website.
Yeah, I think this is one of the most important aspects that everybody wants to know about. So we'll give you the time here, Mohammed.
Okay. Can you see my screen?
Yes.
Yes, we can.
Okay. So this is the EMM Science Data Center website. It will be available publicly at a later date. So if we click on data, we can search and click on Science Data Search page. We can use this page to search for data that we want to find for the science data that we want. So let's say, for instance, I want the data from the beginning of this year. These are test data that are available on the website right now until today. So I'm going to search for the Emirates instrument and the level 0 data. So after I click on search, it will display the available data according to specific parameters that I have chosen. So I can select, for instance, this data that I'm going to download. Then when I click on download file, it will send an email within 10 minutes. So of course, we're not going to wait 10 minutes for this presentation. So I just prepared an email that I have received. So this is an example of an download link that I have received from the EMM-STC website. So when I click on download, I'll be able to download the file. Then once I open the file, I could start working on it. So these are the steps involved to access the science data products that will be available on the EMM-STC website. Thank you all for listening, and if anyone has any questions, you could put them in the Q&A.
Excellent. Thank you very much, Mohammed Al-Falasi, for that. I think there have been a lot of questions on that as well, which is great. So, you know, can the people start registering already, Mohammed?
Not right now.
Not yet. Okay.
Yeah.
So when do we expect that people will be able to have access to be able to start registration?
It will be sometime. It will be sometime after launch, but not directly after launch.
Clear,
but sometime like before the science, almost before the science phase. But I don't have an exact date on that.
No problem. And I'm sure we'll have definitely more sessions, as Her Excellency mentioned, before that time comes, inshallah. Also, a lot of people are asking where we can get the data from and where this recording will be. So we do have a dedicated EMM Science YouTube page, and we'll share that out in the chat room with you all, so that you can access that to those who aren't able to continue with us or want to go back and use this. Also, of course, all the presentations will be available, inshallah. So again, time, we are about 8 minutes behind schedule, not too bad. And please continue sending the questions across. Maryam, Yusuf, you are up next.
Sure. So hello everyone, my name is Maryam Youssef. I'm a science data analyst in the Emirates Mars Mission, and today I'll be talking about Mars visualization tools and models. So what do we mean by visualization tools and models? It basically refers to the techniques used to communicate insights from data through visual representation, and this can be in form of charts, graphs, maps, or plots, and so on. So after the data is collected, processed, and modeled, the relationships need to be visualized so a conclusion can be made. And the visualization tools and models are essential for analyzing massive amount of information and making data-driven decisions. They can be available online or downloadable software, and they have in common, which is called input parameters. You can either put the coordinates, longitude, latitude, local time, orbit, season, and so on. So today I'll be talking about a model called LMD-MCD and a visualization tool called JMars. LMD Mars Climate Database, or LMD-MCD, is basically a model developed by the Laboratoire de Meteorologie Dynamique in Paris, France, in collaboration with several entities. It provides the scientists and provides everyone with reliable and realistic modelization of the Martian climatological system. JMARS, which refers to the Java Mission Planning Analysis for Remote Sensing, as a visualization tool developed by the Arizona State University. It provides us with mission planning and data analysis tools. So what are the similarities and differences between them? The similarities are basically they're both graphical user interface. They provide data of the lower atmosphere of Mars, and the data can be downloaded from both of them, and they're both free of charge. The differences are that LMD-MCD has real data of past missions and modeled data using theoretical methods. However, JMARS only has real data of past missions. LMD-MCD provides data for all the layers of the atmosphere, and JMARS only focuses on the lower atmosphere layer. LMD-MCD is available online and can be installed. JMARS requires installation, and it has an open source. LMD-MCD provides Martian data. JMARS provides Martian data, planetary and other natural satellites data. LMD-MCD displays data on a map format. However, JMARS maps the data on a surface geology of the selected celestial body. So how are we going to use those, the model and the tool and EMM? So EMM data will be compared to LMD-MCD. So by comparing with derived or retrieved quantities, and to understand the behavior of the exhibited data. For JMARS, EMM will use JMARS for analysis and visualization. So JMARS will be hosting the science data product from the three instruments of EMM. The analyses include comparing products of similar data quantities, conducting spatial and temporal comparisons with data from other missions. So we'll be looking at the LMD-MCD model first. We can see here the interface. If you enter the website above here in the link, I'll be putting all the links after in the chat box. So if you click on the link, you will find this page. We'll be talking about the main feature of the model. First, here in the red box, we can see Mars state, where you can put solar longitude and local time. And then the customized coordinates basically are the latitude, longitude, and the altitude. Altitude can be selected above sea level, pressure level, above surface, or the Mars center. So you can choose your variables. There are so many variables you can choose from. You can compare between them. Some are temperature, density, mixing ratio of gases, and so on. And the last thing, which is important of this model, is basically the customized figures. You can choose a format of the figure you're doing the output of. Choose the color of the map you want, and choose a value range, which is basically changing the axes. And choose it for it to be a map, a flat map, or a spherical projection. And then you can choose the transparency and so on. And after that, you can click submit, and you will get the map similar to this. So basically, those are two maps similar to EMM data. On the left hand, we have the water ice, which is going to be similar to EXI data. It's at LS0, so LS0, which is basically the season where hop-up will reach Mars. On the right hand, we can see the temperature variation, which is going to be similar to Emirates data. And here we can see CO column, which is going to be similar to EMU's data. On the left, we can see the flat map, and if we want it to be a spherical projection, it's going to be similar to the one on the right hand. Talking about the JMARS. So basically, if you enter the website, you can see this is going to be the website, and here in the blue box at the bottom, where you can download JMARS, which is available for public. This is the public interface. If you download JMARS, it's basically divided into two windows. The blue box, which is called the layer manager, that controls the data sets and the analysis tools you have put. So by adding a new layer, you have extra layer, either maps or the data you want to look at. And then you can literally drag each layer on top of each other and change the transparency of each layer that you're looking at. The green box basically represents that this layer is active. And on the right hand, we can see the viewing window, which is basically where everything you've put in the layer manager is displayed here. So it's divided into two sections. The upper section is basically the main view, and the bottom section is a panel view, which is basically a wide angle view of the region you are looking at. And you can change the longitude and latitude here from up. This one is basically the EMM version. It's still a work in progress, but the only difference is basically on the layer manager at the bottom. We can see something called overlays. Those are fixed layers set automatically whenever you open the tool itself. But everything else is similar. You can add layers and so on. And the EMM instruments science data product will be available in this version. So here's an example of EMER's stamp layer. For a selected observation, we can see it here on the region we selected. And if we want it to be in a sphere projection, this is how it's going to look like. It's still a work in progress for all instruments. Thus, I only have the EMER stamp layer for now. And this is it for the presentation. So if you have any question, I can answer them.
Thanks a lot, Miriam, for that. Again, extremely detailed, and there's so much that I'm sure everybody is learning here today. Thank you very much for that, Miriam. We have a lot of questions still coming through. So, you know, for all presenters, please go into your questions and answers. It's great. We already have, I believe, close to over 50 questions answered. So those in the chat that are asking, make sure to send them. I believe we are going to be sharing the link here very soon. So please look out for it in the chat. And again, thank you very much, Miriam, for that information. We now have on the science analysis aspect, Hassan Matroushi, please.
Yes, here I am.
Go ahead, Hassan.
Okay. So this is Hassan Matroushi. I'm EMM Science Data Management and Analysis Lead, and I will be presenting for you today the science analyses that the EMM Science team had put into plan to answer the science-specific objectives that we have. So this presentation will outline the roadmap that the science team had put forward in order to gain scientific understandings of the objectives that we have. So each objective, and we do have 3 of them for the mission, we defined the scientific analyses that we need to do in order for us to satisfy the objective that we put into place. And we've defined for each science analysis the data that we need for this science analysis to be conducted, and also the models that we need in order to achieve them. So this puts the science team into preparation before even launch on what is needed to be done after the data arrives. So this is a slide reminder for the 3 questions that we have in the Emirates Mars mission and the 3 objectives that we have. So we do have objective A, focusing on the characterizing the lower atmosphere of Mars, while objective B connects the lower atmosphere conditions with the upper atmosphere conditions, and objective C focuses on characterizing the exosphere, mainly the hydrogen and oxygen corona. So I will go over each objective and what are the science analyses that the team will be doing once the data arrives. At first, we have objective A, which is focused on the Martian lower atmosphere. We do have in here defined 4 scientific analyses that the team will be doing. I will go in details briefly on each one of them. The first one that we have in here is merging individual observations into combined multidimensional snapshot of the global atmosphere. What I mean by that is studying the Martian lower atmosphere using EMM will depend on 2 instruments. The EXI instrument, the one that will observe it in the visible and the short ultraviolet bands, and the EMERS instrument that will see it from the infrared bands. So we would be taking observations from both EXI and EMERS, and we will collect them in a time span of every 10 days because EMM would be able to absorb almost all local times every 10 days. So we would have a snapshot of the atmosphere of Mars
every 10 days, and that will allow us to characterize the lower atmosphere. And as we go forward, every 10 days, we will create these snapshots to have sub-seasonal then observations of the Martian atmosphere, and then a seasonal conclusions and so on. So this will help us understand the behavior patterns of the temperature, how it changes as we go on in time, how the dust changes, water ice, and even water vapor in the lower atmosphere. GeoMars visualization that Maryam had spoke about would be very beneficial when it comes to this analysis. You can see on the right of my slides, there is a panel that highlights the data that will be used for each analysis. So in this case, all the EXI data and Emirates data will be used. The next analysis that we will be doing is comparing products of similar data quantities between EXI and Emirates. Since EXI and Emirates are both looking at the lower atmosphere, we're interested to see the overlap between them. So they are both measuring ice optical depths, both in different wavelengths and different bands. So we would like to combine the information from both instruments to have a more comprehensive understanding of the water ice. Water ice is very important. It plays an important role in the water cycle at Mars. It gives an understanding of the Mars general circulation in the atmosphere. So combining both informations will constrain specifically the particle size of water ice in the Martian atmosphere. So that would be beneficial, and this is something that we're planning to do, and we will utilize even GeoMars visualization to do so. The third analysis that we will be doing is spatial and temporal comparisons to GCM and other observations or spacecraft data sets. Maryam had mentioned this before, that models are very important to be compared to the data that we will get. It will enhance our understanding, it will verify them, it will even facilitate new scientific discoveries if we see that there is a gap in between our understanding between the models and the data. So we will be using all the EXI data, all Emirates data that we have, and wherever and whenever possible, we will compare them to LMD-GCM model and even existing and previous missions retrieval like Mars Global Surveyor, Mars Express, MRO, and so on. The fourth and last analysis that we will do in Objective A is produce a reference climatology using data assimilation technique. Dr. Roland later on will give more detailed explanation of data assimilation technique, but in very simple terms, this is where we create a map without a gap. So we will be using EMM data and theoretical information that we have extracted from LMD-GCM model, and we will combine them both into producing a complete map that gives an understanding in between and bridge our understanding between the models and the data. So this is very crucial into the understanding of Mars climatology and even enhancing our understanding about the Martian atmosphere. So this is where we will be using, to the best of our ability, this data assimilation technique for EXI product and even Emirates product. We will use LMD-GCM and a data assimilation technique that is that will be developed. The next objective that we have is Objective B, which correlates the lower atmosphere condition to the upper atmosphere. We do have 3 analyses in here, which I will go over. The first one is about correlating the conditions in the lower atmosphere to those in the upper atmosphere. So this can be, in very simple terms, done empirically, or it can be aided by models. So this is where we are trying to find the link. Like whenever an event happens in the lower atmosphere, do we see an exciting event happening in the upper atmosphere? And if there is a causal effect or an indication of a link between them, we need them to verify quantitatively whether there is a likelihood that the lower atmosphere event caused the upper atmosphere event. So an empirical correlation is not enough. There should be an evidence through analysis to be conducted how these 2 events are correlated together. The models will help a lot in verifying the linkage between those events. We do have also a 1D photochemical model that the team is working on. that will help simulate these connections. And GMRs, of course, visualization will help a lot in doing so, especially in detecting the links in between them, as it will be very easy using visualization techniques. And for that, we will use all the data that we will have, all EXI, all EMERS, and all IMUSE data, because we need them all to understand the linkage between the atmospheric layer of Mars. The second analysis in this objective is comparing escape rate variations with thermospheric condition. So basically, the thermosphere layer is the lower boundary layer in the upper atmosphere. The thermosphere layer gets impacted by the lower atmosphere events and the upper atmospheric events. So it's very crucial to be understood. And this is where we're getting the link between the lower atmosphere and the upper atmosphere understood. So understanding and correlating the thermospheric conditions with the escape rate variations that we have in the upper atmosphere will help a lot in understanding the linkage between them. So we will try to see how the thermosphere physical parameters, the mixing ratio, the densities are changing in conjunction with hydrogen and oxygen escape rate. If there is a link in between them, and if we find something, we will try to simulate it. We will try to find out how likely these events are correlated to each other. So there is a model that we will use to do that, thermospheric hydrogen and oxygen production models. This will help us to verify our understandings and whatever we see from EMM data. The third analysis is analyzing episodic events. So this is very general. Episodic events are natural phenomena that they happen on Mars, but these events will definitely have an impact in Mars atmospheric circulation. So we need to take them into considerations. We do have an outlined 5 events that we're taking into consideration and we would like to study. The first one is dust storms' effect on escape rates. Everyone knows about the global dust storms that happen at Mars. These are very crucial. They affect the balance and the constituents in the lower atmosphere, and they even impact the upper atmosphere. There's a lot of studies that are ongoing that tell us that these dust storms impact the escape rates of hydrogen and even oxygen. So we would like to look into this even more. We will utilize the LMDGCM, we will utilize GMR's visualization to detect even the dust storms impact and where they are and how we can link them to the upper atmospheric components. The second episodic event that we will look into is the solar flare effect. So basically solar flares are local events. They release a huge amount of energy that causes disruption in the atmospheric balance. Although EMM is not measuring directly solar flares, but we would be able to see the impact of the solar flares on the thermosphere layers and the upper atmosphere of Mars using EMM. So we'll be using EMM data, specifically IMUSE data, to see the impact of the solar flares and evaluate them. And then we will use EUV data from other missions or interpolated from Earth to do the linkage between them and evaluate them. The third analysis is about solar energetic particles and coronal mass ejections. Basically, these are related to the sun activity. So SMEs, which are coronal mass ejections, are huge amount of coronal plasma and magnetic energy that are pumped into space. And then the SEPs, which are the solar energetic particles, are the eruptions and the energetic ions that are traveling through space, and they usually have an impact in the upper atmospheres. So there are studies that have been ongoing on the impact of those events on the Martian atmosphere, and some of them indicate that they impact and increase the hydrogen escape rate. And that's why we're putting them at the list of events that we would like to look into. So whenever they happen, we will do some studies to understand their impact on Martian atmosphere. We'll be using the LMDGCM. It will be very helpful, and even the thermospheric hydrogen and oxygen production models. EMM as well will not measure SEP and CME directly. We'll be measuring the impact on the data that we have. Those information will be taken from other instruments that are available out there or will be interpolated. The fourth event is polar cap variabilities. So basically Mars has two polar caps. They consist from carbon dioxide and water ice, and these caps are not consistent. They vary in terms of size and temperature depending on the season. So these are events that we will look into as well to evaluate the impact on the Martian atmosphere circulation. We will use LMDGCM and GMARS visualization. And to evaluate the polar cap, we will use the visible images from EXI to see how the changes are happening, and we will utilize the temperature from EMIRS instrument. Same data as well will be used to study the fifth analysis and the fifth episodic event, which is dust deposition and removal events influencing surface temperature and albedo. So we know that Mars is full of dust, and the global distribution of dust is very key and understanding Martian geology and climate. So that's why we would be paying a close attention to it, and we will use GMARS visualization and MGCM to do that as well. So that concludes our analysis for objective B, and we can go directly to objective C, which is focused on characterizing the exosphere, which is the upper atmosphere of Mars. We do outline 3 analyses that the EMM science team are planning to do in order to gain the scientific understanding for this objective. The first analysis is comparing the densities that will be derived by MUs to models predictions. So MU is one of the products that we will get out of it. As you can see on the bottom is the densities of hydrogen and oxygen, and these will be available through the Science Data Center. We would like to compare these densities to the model's predictions or even other mission satellites and data. This will help this comparison will help them to understand the variations between the data products and ultimately providing us new knowledge about the Martian atmosphere. Any differences will intrigue missing physical parameters that we don't know about that can open a lot of doors for us to understand more the Martian atmosphere through these comparisons. So we will be using MGCM to know our expectations and understanding for these densities, and we will be using thermospheric hydrogen and oxygen production models to simulate that. The second analysis that we have is deriving the escape rates from exospheric densities. So this is very important because we are measuring the densities of hydrogen and oxygen in order for us to know the escape rates of both elements. These are the components of water. So we want to know how much escape rates we're dealing with. So this is one of the things that we will do as part of Objective C, is deriving those escape rates. And for that, we need 2 things. We need the densities and we need some models to do that. So we have a 3D oxygen photochemical escape model and 3D hydrogen genes escape model to calculate these densities, and an additional hydrogen atom microphysical model that we will need. So these will help us do the calculations for the escape rate. And the last analysis would be taking these escape rates that we got from science analysis number 2 and then compare them to model predictions and even other teams' calculations. So by the comparison of these escape rates, we will know whether our current models that we have are doing a good job, whether something is missing when it comes to it, whether maybe some elements or some physics in the atmosphere were missing that are contributing to the escape of these elements or not. So any differences will bring new information and on the current Mars atmosphere processes. We will be using LMDGCM and the 1D photochemical model when it comes to it. So this concludes my presentation. I hope you gained a lot of insight on what the team had set into plan in order to achieve the science objectives that we have for the mission. And if you have any questions, please put them up in the question and answers tab, and I will be happy to answer them.
Thank you so much, Hafsa, for that. I mean, that was, again, a very detailed, very technical information. So I'm sure all of the students and entrepreneurs out there looking at what is happening and looking at all the available tools that are expected to come up and of course, all the analytics that are there behind all the data that'll be coming in is definitely going to be huge. Hessa, we have sort of, some questions coming in terms of, have you made use of AI today to support in analyzing the data?
So artificial intelligence can be used to detect maybe interesting features that are existing within the data, but a lot of the scientific interpretation would need a human being utilizing their knowledge about Mars and the atmosphere, what we know, into interpreting it. It's not something easy that we can link into it and get a result out of it. There is a lot of scientific understanding that has to be done in order to understand and bridge our understanding and what we do not know about the Martian atmosphere.
Thank you. And another aspect or question that is coming through in terms of I guess if you could just touch on the communication ability between the orbiter and Earth. How often will you be in contact with it, and how much data is expected to come through, and in terms of the autonomous features that are built in?
All right. So we do have already, the mission planning team already defined how often we will get in contact. It depends where the HOPE probe will be located, and when do we have access to it. So whenever we have a connection going on, we will download all the data that are residing on the HOPE probe, so we can go ahead and analyze it. Whenever the probe is not in sight, so maybe it's behind Mars and we cannot do any communication to it, it will keep storing the data, and once we get a connection, immediately it will get. So everything is planned. I don't have the exact, but they have it orbit by orbit, like when do we need to do the communication and when we are downloading the scientific data.
Excellent. Thank you very much, Hessa, for that introduction on the science analysis aspect. And I think, Moza, you are up next. I think this is definitely interested a lot of the students. We're getting a lot of people telling us, the different majors that they're in, their different universities they're in, their interest to be able to be a part of the science. So I think Moza will hopefully be answering a lot of your questions here today. Moza, the floor is yours.
Thank you very much, Fahad. Just give me a moment to share my screen. Okay, hi everyone. My name is Moza Sharif. I'm the Science Initiative Coordinator in the Emirates Mars Mission Science team. So for this presentation, we'll be talking about the EMM Science Outreach programs. So just to give a brief introduction to the outline, we'll be highlighting the mission education and outreach objectives. Then we'll move on to talk about the EMM Science Outreach programs. We will be highlighting in this presentation the 4 operational programs. Other than those 4, we do have other workshops and activities that will also be mentioned by the end of this presentation. So various science outreach programs were introduced since EMM was announced, and those programs were developed in order to run and fulfill the overall education and outreach objectives of the mission. And those objectives include promoting space science education and research in the UAE, and to engage and involve the public from all age groups in the mission. So we consider students, whether they are undergraduates, graduates, postgraduates, and professors, researchers as well. So basically everyone, including the general public, in various programs, events, and workshops that we offer. Another objective is to build capabilities in STEM fields within UAE schools and universities, and building capabilities in space science research, and specifically in Mars science within the UAE. Moving forward, these are the 4 outreach programs that I'll be talking about in this presentation. So the first one is the Research Experience for Undergraduates program, also known as the REU program. Then we will move on to talk about the EMM Research Grant program, and the Explore Mars poster competition, and the annual EMM Science Workshop. So to begin, we'll talk about the REU program. And the purpose of this program is to stimulate the students' interest in the space science and research fields, and it is targeted to undergraduate students from science and engineering majors. So just to give an overview and a brief description about the RU program, it's an international internship opportunity for undergraduate students in collaboration with MBRC's partners. Those partners will be highlighted on the next slide. And this internship is usually for 8 to 10 weeks, and where the students are mentored by the Emirates Mars Mission Science team or by international scientists. Usually the projects include data analysis or systems modeling, and mainly highlighting a Mars research project. And before the student begins with the RU program, they are usually prepared by an RU bootcamp, which is a series of presentations and workshops that highlight the Emirates Mars mission, the instruments, and how to conduct research, and basically all the variables included on how to conduct scientific research before they begin with their RU program. Once they start, they are assigned with a project and a mentor and tasks in which they are able to result to having publishable results in which they can attend international conferences and discuss basically the research findings that they have come up with throughout their program. So here are the partners. The student, whoever gets accepted to the RU program, can either be mentored by a member within the EMM science team at the Mohammed bin Rashid Space Center, or a mentor from the Laboratory for Atmospheric and Space Physics at the University of Colorado in Boulder, or Space Sciences Laboratory in the University of California, Berkeley, the Northern Arizona University, or the Dynamic Meteorology Laboratory in Paris, known as LMD. So what are the students expected to do throughout the RU program? We usually request the students to provide a bi-weekly progress report highlighting the work that they have done, considering that there is a boundary between us that it's not somewhat in real time. So we usually request bi-weekly progress reports that can also highlight any concerns that they may be facing throughout the program that can be resolved from our end. And the students need to be fully invested in the tasks or assigned work for 40 hours per week by utilizing heavily their programming skills. And they also become an integrated member of the team and work actively with the mentors. This includes attending meetings and updating the other students in the program, for example, with the work that they have done. In addition, mentors will ask the students to prepare any presentations, scientific papers, and posters that can present any research findings to the team or the other students or the other mentors as well. And as always, the students need to represent their culture in a positive manner wherever they are. So what are the benefits of joining the RU program? Distinguished students would potentially be offered a full-time scholarship to pursue an advanced degree in science or engineering field, or they can also directly join MBRC's Emirates Mars Mission Science team on a full-time basis. So this is if you were identified as a distinguished student by the end of the RU program. And also the projects that they work on throughout the RU program can act as an initial step to their senior thesis project within their own universities, and can act as a great prerequisite for any graduate level science or engineering program that the student may apply to in the future, whether it's master's or PhD or anything regarding their career path. So this is the number of RU students per year since its initiation in 2015. So far, we've had a total of 29 students as of 2019. For 2020, because of the whole COVID-19 situation, we are planning for a virtual RU program, which is still in the works as well. But overall, we've had a total of 29 confirmed students within the RU program. From those 29 students, there have been a total of 18 publications that have been submitted to international conferences, 12 being posters, 2 as oral presentations, and 4 journal submissions. And more to come when more students are on board the RU program as well. Here are some photos of the students. As I've mentioned, these publications can include poster submissions, presentations, or talks, for example, that they can share the research that they have conducted to international scientists to gain feedback and to further improve the work that they have done as well. So next is the EMM Research Grant Program. And the purpose of this is to stimulate the students and faculty in the UAE to focus on planetary and interstellar related themes through research and development. And the target is basically the UAE science community, which consists of professors and undergraduate, graduate, and postgraduate students, researchers, and scientists. So the objectives of the grant program is to recognize the importance of research in the field of science and research and development, and to stimulate the students and faculty in the UAE to focus on planetary and interstellar related themes. So when they come to submit a research project under the EMM Research Grant Program, it is one of two tracks. They can either submit under a Mars atmospheric science track or a space science track. The difference between those is the fact that any project highlighting Mars that is aligned with answering the EMM science questions and utilizing the EMM datasets to answer other science questions fall under the Mars atmospheric science track, whereas the space science track is open for topics related to planetary science, solar and stellar astronomy, as well as any other studies related to our galaxy. So just an overview on the projects that we have. We have a total of 2 projects under the Martian Atmospheric Science, one from the University of Sharjah and one from the American University of Sharjah. The total of 7 students are a part of those projects, and a number of 7 publications have been submitted to international conferences from one of those from those 2 projects as well. As for the space science project, there's a total of 3 projects under the space science track, 2 from the American University of Sharjah and 1 from the New York University of Abu Dhabi. And there's a total of 18 students in those distributed among those 3 projects, and a number of 26 publications to international conferences as well. Next, I'll be talking about the Explore Mars competition. And the purpose of this competition is to stimulate interest in Mars missions design and sciences in university students and develop their research skills, basically. And it's targeted to undergraduate students from science and engineering majors. So a brief description on the Explore Mars competition. It's usually held side by side with the annual EMM Science Workshop, which I will be talking about in the next coming slides. And it's open for undergraduate students with a passion for learning more about Mars. And the main concept of the competition is that they present a research proposal in a poster style. And the poster submissions should propose a future research with a focus on geology, atmosphere, and the habitability of Mars, and should highlight a novel Mars mission design or instrumentations as well. Just to add, usually the concept of the competition is always the same, but throughout the years we've managed to change it up a bit to keep students interested in this competition. So in the beginning we've had a beginner and advanced track, and once upon a time it was open for all students, including graduate students. This year we've had a change of theme where we made it into a challenge in which the students should highlight a scientific factor and the engineering factor in the research proposal that they submit. And finally, the winners of the competition are usually awarded with a monetary award. So a total of 70 students have participated in this competition since its launch in 2016. And here are just some examples of those posters. So as you can see that there are that they include a lot of literature reviews, a lot of details towards scientific explanation when it comes to basically explaining their research proposal, and in which they get feedback from the international science community that are also available on the day that they present. Finally, I will be talking about the annual EMM Science Workshop, and it is to provide an interactive platform to enrich the UAE's community with Mars science and ways to contribute to the Emirates Mars mission. And basically this workshop is open to the UAE science community, which consists of professors, undergraduate, graduate, and postgraduate students, and researchers and scientists who are interested to know more about Mars science. And since 2015, the Emirates Mars Mission science team hosts the annual science workshop yearly to focus on Mars atmospheric science. And usually this workshop aims to provide an overview about Mars as a planet and its evolution and the science behind it. And throughout this workshop, interesting topics are presented by the EMM science team, by international scientists as well. And we also involve the students who are part of the programs as well. So they don't basically end when the program just ends. We usually encourage them to take part in these in the workshops that we announce as well, and any opportunity in which we can get the students on board where they can present and get feedback on the research project that they've worked on. And finally, we have other activities that we also work on that include the EMM Science Week, which are a series of presentations and interactive workshops that is mainly open to the general public, which include the basics of Mars, and any contribution we have towards camps as well are introduced. So we've had the Like a Scientist summer camp, which was tailored to high school students to know more about Mars science. And whenever there's a seasonal school holiday, MBRC usually announces the Space Explorer Summer Camp, in which the EMM science team does have a contribution towards that when requested. And finally, any request coming from universities, we usually attend to that. An example is the freshman year projects, which is a course freshman students take where they mainly work on engineering projects. However, so far Khalifa University have requested this, and they wanted to involve space science into the course. So 8 projects were created for this course, and the groups get to decide on which projects that they would like to work on for the freshman year projects. And this concludes my presentation. So if you have any questions, please feel free to add them to the Q&A section of this discussion.
Thank you very much, Moza, for that. So as you can all see, there is a lot of efforts going out when it comes into the science outreach and going out to getting people involved. Now, Moza, some questions. So I see you've already picked up students, over the years. Will this continue even after the mission operations have started? Or, as people need to be trained in preparation to be effective and understand the the data and all the tools around it. Will that continue? So you mentioned in 2020 you will be looking at a possible virtual group.
Yes. When it comes to any outreach programs, we are still planning to continue this even after launch. So whenever there's an opportunity, we usually announce it out to the students and the faculty within UAE universities to apply to those and to get more feedback. To get more insight towards Mars science and research.
Excellent. We have a lot of students as well asking in terms of how they can apply and how they can reach. Could you give us a quick direction to those?
Well, I'll be I will be replying to the respective emails, because each program has a specific email that they can inquire more about. So I will be sending those out as responses to those inquiries. So whoever
Excellent.
wants to know more can just mention that, and I'll be responding to those.
You mean they should email someone at MBRSC, or are you mentioning in the questions in the Q&A box that we have during the session?
And the Q&A box, basically.
Okay, all right. So you all heard. Thank you so much, Moza, for that. I mean, it's also great in terms of the outreach that's been done for the students and the camps and things. You know, I know I'm still, as you guys all know, it's just 4 months on the job for me here when it comes into space. So I still have a lot to learn, and there's a lot happening. We'll definitely, through the UAE Space Agency as well, be collaborating with the Mohammed bin Rashid Space Center for those of you who are connected to us, so that we can make sure we're distributing all that information out to everybody, all the students and all our participants, so nobody feels left out, inshallah. Moza, another question is, I think people are asking, so we have some international attendees here. Is this only specific to UAE students and residents, or is it open to the international domain as well?
We have, for example, the RU program is open for, usually it's for Emirati students, even if they are living abroad, they are able to take part in that. However, we do have, so far we have the Explore Mars competition that is open, for example, to all nationalities to take part in. However, throughout the coming few months, we are planning to have more programs as well, which can include everyone, because we also don't want to disclude anyone from being part of the mission as well.
Excellent. Thank you very much, Moza, for that insight and all that information. Questions are still coming. I think we've had over 80 questions answered today by our team in the background. Thank you all so much for doing that. Keep your questions coming. Inshallah, we'll hope to continue answering them. So next up, that is, I guess it concludes the EMM science aspect from the MBRSC team. And now we're going into the next stage of our presentations, where we now have Roland and Klaus from the NSSTC to talk about the center, the updates, and also their involvement when it comes into the EMM science. Klaus, Roland, the floor is yours.
Thank you very much. Let me share my screen. Okay. Okay, I hope you can see my my presentation.
Yes, we can.
Thanks. So I'm going to give an update about the National Space Science and Technology Centre's involvement with the Emirates Mars mission. This is going to be in two parts, myself and my colleague, Dr. Klaus. The NSSTC is a research institute. It's part of the UAE University in Al Ain. And one of the things we are doing is we are building capabilities in research into Earth and planetary science topics. We are building an Earth and planetary science unit involving researchers and students studying various aspects of Mars atmosphere and other planet atmospheres, including Earth. And one of the things that is very important to us is to train the next generation of Emirati planetary scientists. So part of this, a very important part of this, is our collaboration with the Emirates Mars Mission Science team. And this involves two research projects which recently started, both started on 19th of May to run for 3 years. And I will discuss the second of these, but first my colleague Dr. Klaus will give an overview of the project he's leading called Dynamics of Mars Dust Storms. And then I will talk about EMM data assimilation, which was briefly mentioned earlier on. There are several opportunities for students to take part in these projects, as well as researchers, and these are summarized on the right. We have currently advertised PhD and MSc studentships for UAE nationals for realistic entry in spring 2021. There are two links here, which I will put up on the last slide as well, so you can take those down if you're interested in contacting us about those. We will also be advertising some researcher positions, and these are listed here on the right as well, related to both of these projects. So anyone who's interested in those, please get in touch with us. I'll put our contact details on the final slide. So now Dr. Klaus will summarize the research project, the first research project on the dynamics of dust storms. Klaus?
So thanks for the introduction. Mars dust storms are a research topic of high interest. That's because they have implications for the engineering parameters and the entry, descent, landing operations of spacecraft, also for the energy production by the solar panels of Mars rovers and landers, and as can be foreseen, the safety and health of future astronauts on Mars. A striking example is the loss of the Mars rover Opportunity during a global dust storm event by mid of 2018. In the middle of this slide, we have a picture how Opportunity looked like when it left the clean room. On the right, we have a kind of futuristic picture with future astronauts at the final resting place of Opportunity. Next slide, please. First, note that existing satellite orbiters map dust storms at a temporal resolution of 1 day. The new approach by EMM will be as follows. EMM will achieve a temporal resolution of few hours as a result of its unique orbit. Moreover, data assimilation will provide a comprehensive four-dimensional data set of the Mars atmosphere. There will be more information on data assimilation in the second part of this talk. Data assimilation is the basis for the companion of the Mars dust storms research program. Next slide, please. The dust storm dynamics research program is directly aligned with EMM Science Objective A, and it may further support Science Objective B. Next, please. The dust storms program has a number of project goals. There is a project goal 1, innovative studies on dust storm dynamics based on EMM. We have project goal 2, technical feasibility study using existing satellite images. And last but not least, we have project goal 3, that's the simulation of dust storms using Mars global climate models, so-called MGCMs. These goals will address various research questions, such as why does a certain area experience the onset of dust storm activity on a particular day and not few days earlier or later? What factors make some dust storms grow to large scale and others not? What are the implications for the future predictability of dust storms, and many more research questions. Next slide, please. Then a few words on the methods. The manual identification of dust storms by the visual inspection of satellite images is common practice. Manual identification of dust storms is actually the basis for an exhaustive list of scientific literature. Of course, also comparisons against automatic dust storm detection methods based on artificial intelligence and deep learning is an interesting perspective. On this slide, we have also some demonstration of the state of the art. The camera instruments of existing Mars orbiters provide Mars daily global maps, so-called MDGMs. We have here 2 example MDGMs. One was by January 25th, 2002, the other one a day later. MDGMs are maps of the Mars surface on a daily basis. In the first MDGM, some regional dust storm was spotted at the northern high latitudes. Hope everybody can see that. In the second MDGM, it is evident that the dust storm was already rapidly moving from the north to the south. It had progressed a distance of about 1,000 kilometers at the time. Because of the temporal resolution of 1 day, there's actually no information on what was in between. The idea is to fill such gaps by EMM. And now we come to the data assimilation program. I give back to Dr. Rowland.
Okay, thank you very much, Klaus. So I'm going to summarize the second research program. And this is using a technique called data assimilation, which is a very well-established method used in atmospheric science, where we combine observations systematically with our best theoretical understanding, which is usually encoded in the form of a weather model or climate model. And the idea with the Emirates Mars mission is that we will have a platform to obtain a huge number of observations of the Martian atmosphere. And our goal is to combine all of the infrared and visible observations with a Mars global climate model. The headline thing to take away from this is that EMM, for the purposes of data assimilation, will be the best spacecraft ever sent to Mars, primarily because of its orbit and the way that it observes the atmosphere, which I'll come back to. And we will use this to produce various data products, climatology, which can be used to study many atmospheric processes in pursuit of EMM's scientific goals, studying all of those atmospheric phenomena that are listed there in the bottom right. So the basis of data assimilation in principle is it's a way in which we combine all available information about a particular phenomenon at a particular moment in time. So imagine you're sitting in a room, you have 10 people in the room, and you want to know what the temperature is in the room. So you could make a forecast of the temperature in the room by asking each of the 10 people to estimate it, and that would give you a forecast. It would give you a mean and an uncertainty in some sense. But then you could also take a measurement of the temperature using a thermometer, and this would give you a second measurement, a second estimate, in this case an observation, but also with an associated uncertainty. Even a thermometer doesn't measure temperature precisely. Now, data assimilation is the formal synthesis of these two sources of information to give you what's called an analysis, which combines the information from the two, and in principle is closer to the true temperature in that case than either of the two, either the forecast or the observation alone. And this can be written down mathematically, shown there in the bottom left. So this principle can be applied very, very broadly, and it has several powerful aspects. So here on the right, you can see a video of a laboratory experiment, which in some ways simulates the large-scale behavior of the atmosphere. And you can make measurements of the speed of the fluid. For example, you might take measurements of the fluid speed and get a set of fluid vectors looking like this. Now, if you have a simulation of this experiment, you can assimilate the data into the model. And the first powerful aspect of this technique is that the model's internal consistency fills in the gaps between the observations. And so you're able to retrieve what the system is doing in locations that you did not observe. The second powerful aspect is that, again, because of the model's internal consistency, you're able to retrieve quantities that were not observed at all. For example, in this case, there is a relationship between temperature and wind speed, or speed of the fluid. And so you can retrieve a temperature field from velocity observations. So this is a very powerful approach that can be used to study many phenomena, and it's been used to study Mars for some time, and used to study the Earth, and it's a critical part of Earth weather forecasting. So for Mars, we combine a weather or climate model of the Martian atmosphere with spacecraft observations that will come from EMM. The primary observations we will use are from EMIRS, they are atmospheric temperatures, and the secondary observations we will use from EMIRS and from EXI. These are measurements of the amount of column aerosols, dust, water, ice, and so on. And then the third component is the combination of those two using data assimilation. The reason that EMM is particularly well suited to this is due to its particular orbit and the combination of the two, the infrared and the visible instruments. Because of the orbit, it's able to look at all local times of day. Imagine all we knew about the Earth's atmosphere was by observing the atmosphere at 3 p.m. and 3 a.m. There's a lot of information we would not know, but this is in fact the case for Mars to some extent at the present time. EMM will be able to fill in many of the gaps in that sense, and also it is able to observe complete full areas of the planet at a single time, simultaneously, and this means we can instantaneously capture complete weather patterns and things, transient phenomena. And so, as a result, we believe that this will be the best platform ever sent to Mars for the purpose of using this process, data assimilation, to produce a complete atmospheric state that includes both observed quantities like temperatures and aerosols, but also unobserved quantities like winds, which are very difficult to measure at Mars. So the final slide here, just to illustrate the specific goals of this project. The first is before arrival at the planet, we're essentially going to be doing a technical task that will prepare the simulation architecture to take real data to incorporate real data as soon as we arrive at Mars. And this is called an observing system simulation experiment, where we essentially simulate the observations that will happen when the spacecraft gets to Mars, and use that to train the simulation scheme and to do some. There are some useful science that can come out of this too, but this is primarily a technical task. The second goal will be to assimilate temperature observations from EMIRS, from the thermal infrared instrument. The primary quantity to assimilate is atmospheric temperature, but we will also in time assimilate surface temperatures, which I believe has never been done at Mars before. And the technique that we use here is that other critical meteorological variables like wind and dust, very important for Mars, are updated using their correlations with temperature. And this has proved to be quite powerful in the past. The third stage will be to combine the EMIRS and EXI observations to assimilate observations of aerosols, dust, water ice, water vapor, and ozone. And this is quite a challenging target, because each of these quantities affects the way the model behaves in different ways, and in combination, this can be quite complicated. So it will require a lot of thought to do this well. But we hope by the end of this, we will be able to assimilate all the available data from these two instruments and produce a very comprehensive climatology of the Martian atmosphere. So just to finish, I'd like to show one slide on the potential PhD and MSc projects that people can get involved with for both of these projects. So the PhDs, for the project on dust storms, this project will be studying dust storm statistics based on imaging, EXI observations primarily. And for the data assimilation work, the PhD project will be a self-contained project that will attempt to assimilate both EMM and lander observations. There will be several landers active on the surface by the time EMM is going into various local models on a much smaller scale than globally. And there are various MSc project topics that can be that are possible as well in both these projects. Ideally as part of the MSc in Space Science, which is about to begin at UA University. So that is a summary of what we're doing with EMM, building capability at NSSTC to work on this mission, and we hope in the future further planetary science missions that the UAE is involved with. So I will leave those details up in case anyone wants to copy them down, and thank you very much for your attention.
Excellent. Thank you so much, Roland and Klaus, for that. Yeah, please keep that page up for everybody to capture the context there. Okay. So as you heard, NSSTC is, they have a lot of projects ongoing. They're part of the EMM science team. They've been doing a lot of work in the background and preparing all of this here, all in line for them to get new, fresh, real data from the Mars probe, inshallah, in the future. The opportunities are of course, something that everybody is always looking for. And so you have the emails available there. And, you know, this is great because we have a lot of students asking how they could participate. We have students actually from the UAE University asking. And these are great opportunities for you all to join. And I'm sure Roland and Klaus, you know, will be happy to receive your emails and be able to direct you. Another aspect, you know, when it comes to the NSSTC, it is still a growing center. Roland, could you advise, or Klaus, you know, the expectation of when the NSSTC is going to be fully up and running?
Well, NSSTC as a center has been operational for a few years.
Yeah, I mean the new AIT capabilities.
The new AIT capabilities, I believe. Dr. Khalid will correct me if I'm wrong, I'm sure, but I believe that the AIT building will be starting to be commissioned in the early fall of 2020.
So I assume there will be a lot of opportunities there for a lot of hopeful masters and PhD students to come into that.
This presentation is about EMM, of course, but those links include a large number of projects, not just in planetary science and Earth observation. They include projects in all areas that NSSTC covers, including space instrumentation, radio science, and other such projects.
Excellent.
Perfect.
Yes.
Note, some test facility for small to medium-sized satellites is currently under construction. This will include thermal vibration and other tests of satellites up to 250 kilograms. The building is almost ready. I think that's also relevant to the question on the operations of NSSTC.
Yes, thank you very much. Yeah, so I hear as well, Sarah Al Amiri saying that the facility will be ready by August. I think that'll be the soft opening. I think there's a lot of validation testing and aspects going to be happening. And I believe, as you guys mentioned, the official launch will probably be during Q1 of next year. And it's great. There are a lot of different partnerships happening to bring a lot of new capabilities into the UAE and into the facility. So thank you very much, Roland and Klaus, for that.
Thank you.
Next up, we have Dimitra from NYU. Dimitra, the floor is yours.
Hi, everyone. Let me just share my screen.
So we're still doing exceptionally well in terms of time, I think, because a lot of the questions we were trying to leave for the end, but we have over 90 questions have been posed and answered. So Dimitra, please continue. Let us get some more questions out of your presentations here, inshallah, and get those answered as well.
Cool, thank you. Thank you, Engineer Fahad, Abdullah, Dr. Fatima, and everybody for organizing this and inviting us to present our work at this event. So my name is Dimitra Attri. I'm a planetary scientist at the Center for Space Science at NYU Abu Dhabi. So let me start by giving a quick introduction to what the Center for Space Science is, what our objectives are. So we have been operating for a number of years at NYU Abu Dhabi. The main objective of our center is to position the UAE as a world leader in scientific discovery and innovation. We are proud that His Excellency Dr. Al-Ahbabi is on our board of advisors, and we had a very productive meeting with him earlier this year. We carry out world-class research in solar and stellar physics, in planetary science. We study how stars and our sun interact with planets, with Earth, with Mars. Our priority is to support UAE's innovation priority sector, which is space. We have a large number of Emirati students. We have students from all over the globe, from 84 countries, the new incoming class. And so we have a variety of talent with us. In terms of personnel, the center is led by Professor Srinivasan, who was there when we had our meeting in Crypto Labs before the pre-COVID era when we used to have face-to-face meetings. Professor Srinivasan is a world-renowned expert in many areas of physics, and he leads the Space Center. He divides his time between New York and Abu Dhabi. In addition to that, we have a number of co-investigators. Muataz and Ian are both based in Abu Dhabi. Laurent is the director of Max Planck Institute in Solar System Research, and Shravan is a faculty at the Tata Institute of Fundamental Research in Mumbai, and they are also actively participating and directing our research. We have a number of postdoctoral scientists in our center. All are based in Abu Dhabi. We have one graduate student, Shane, who is a global fellow from New York, who is also based here. And we have Azza, who is our student researcher. We are proud to have 2 Emirati women as a part of our team, and we plan to include many more. So let me start with the research side. This is an overview of the research on Mars that we do at the center. So we study Martian atmosphere in great detail, in particular how the solar radiation interacts with Mars. And today's presentation is focused on that, so I will not expand on this right now. Another project that we are leading is assessing the impact of ionizing radiation on astronauts on crewed missions to Mars. This is also aligned with the Mars 2117 program. And so we are leading a very large international collaboration where we are looking at astrophysical data, medical data, and assessing the impact on long-term space missions. Azza is a part of that. Then we have an exobiology component, possibility of life below the surface of Mars. There was a mission, ExoMars mission, which was supposed to be launched in July this year, but they had issues with their parachute, so it got postponed. It will be launched in 22. It is going to dig 2 meters deep below the surface of Mars, and so we have research in that direction too. We also work in the policy sector. We are working on a paper right now where we are discussing how the human exploration of Mars could lead to better sustainability on Earth. So we have a variety of research programs centered around Mars. So for today's thing about EMM, our main focus is how space weather interacts with Mars. So as we know, sun is so important to us, how it impacts Earth, and so it impacts Mars. So space weather are all the different events that happen on the sun. It can be categorized as solar wind, solar flares, coronal mass ejections, solar energetic particles. We heard about them in our previous talks, how different types of events are being studied with, are going to be studied with EMM. So in all these events, broadly, you have 2 types of radiation. One is photons, this normal light, but of very, very high energy. And you have charged particles, and they both interact with the Martian atmosphere. You have extreme ultraviolet range, which interacts with Mars. It heats the atmosphere. It causes a number of physical processes on Mars, such as excitation, ionization, etc. Then you have other events such as CME, solar energetic particles, etc. They can produce energies up to 10 billion times higher than what we see in normal light. So they can be extremely dangerous. They can lead to electromagnetic and hadronic interactions with the Martian atmosphere. And so all these different types of space weather events, they also interact with Martian atmosphere in different locations. So for example, XUV, although it is highly energetic, these are photons, and they impact the upper atmosphere of Mars. Solar wind, depending on its energy, it can penetrate a bit deeper. These are charged particles. You have solar proton events. They can not only impact the upper atmosphere of Mars, they can penetrate much deeper. In fact, there was an event observed in 2017, very recently on Mars, where the particles were able to go down to the ground level. So they impact the lower atmosphere as well. Plus, you have the background radiation from galactic cosmic rays that is always there, and it goes all the way below the surface of Mars. So all these different types of radiation, they interact with Mars in different ways. Now, how do they impact Mars? So on the right, you can see there is a nice picture. It looks very complex because the process itself is very, very complex. On the upper left-hand side, you have different types of radiation coming from the sun. It interacts with Mars in different ways. And the two main processes that we want to study with EMM, it is atmospheric escape and atmospheric chemistry. So when this radiation interacts with Mars, a part of the atmosphere escapes the gravity of Mars and eventually leads to the erosion of Martian atmosphere. Mars currently has a very thin atmosphere. And so one idea is that Mars had probably a thick atmosphere in the past, and eventually because of solar radiation, it eroded. This radiation also interacts, causes ionization, and it creates changes in chemistry in the Martian atmosphere. There are a number of channels of escape listed here, and so each of them is calculated in a different way, and we try to combine them, and that's our effort. So it's a very complex problem, and it requires a number of numerical models. And so right now we are in the process of testing and developing these models so that we are ready by the time EMM data arrives. So the most important instrument we heard in a previous talk is the EMUS for us. It is an ultraviolet spectrometer on board EMM. It is one of the three instruments. It images in far UV, 100 to 170 nanometers. In particular, it explores two different sectors on Mars. One is the thermosphere, 100 to 200 kilometers. And the second one is the exosphere, which is above 200 kilometers. And it is going to measure the column abundance of oxygen and carbon monoxide in the thermosphere. Plus, in the exosphere is going to measure the density of atomic oxygen and atomic hydrogen. And these are the species that we model in particular in our models. And so it is going to be great that we can get direct data from this instrument so that we can do science. So one of the main models that we use is Geont4 Mars. Geont4, in fact, is a huge package developed at CERN. We all know about the Large Hadron Collider, discovery of the Higgs boson. And they study how charged particles interact. And so they have an open source model available. We have modified that model to work with Mars so we can understand how any type of radiation interacts with the Martian atmosphere. It is an in-house developed model. So we at NYU Abu Dhabi have developed it. We have validated it. We can understand anywhere on Mars the energy distribution of charged particles, photons, how much heating it is producing in great detail. And so it is great that we can compare our model with observations. And the idea is to use this base model and couple it with other models, for example, escape models or chemistry models. Another model which is in development is DSMC Mars. This model specifically calculates escape rates. Our graduate student Shane Carberry-Morgan, it's a big part of his PhD dissertation. And so one of the main objectives of EMM is to look at Martian exosphere. And so this model specifically calculates. It looks at atmospheric escape at molecular level. And and the part in development right now is to implement photochemical escape to look at hot corona in the upper atmosphere of Mars. And as you can see that EMU's level 3 data is going to give us the 3D density distribution of hydrogen and all around the planet, and which is directly going to be useful to us.
Mitra, I just want to pull you into the time aspect, please.
Yeah, I just, thanks for that. Yeah, so overall we have 4 numerical models that we are going to use to carry out these studies. One is using XUV radiation, how it interacts with Mars. I already talked about GEON4 and DSMC. We also use a model developed at Michigan, the Mars Global Ionospheric Thermospheric Model to model atmospheric chemistry and escape. And we aim to finish all our validation by December 2020 so that we are ready for EMM. As you can see, this slide summarizes how our research is aligned with the objectives of the EMM mission. The first one, the objective A, that is the least aligned with us, except in case of extreme events which can directly impact the lower atmosphere. But all our work is focused on objectives B and C, and we have already heard a lot about that in our earlier talks, so I will not elaborate more on that. We do have computational resources not only for us but for other researchers in the UAE. We have a National Center for Space Science National Data Center, which is going to host data from a large number of missions. And so if you want to do a combined analysis from different missions, you can access data from there. We are building capability to facilitate pre and post launch studies associated with EMM. We are running all our simulations there. For the National Data Center, we are currently doing testing, and it will be released, it will be available in the public domain very soon. We also have a high performance computing cluster. All the data analysis and simulations need to be done. We have 385 teraflops computational capacity, 6 petabyte storage. I know that MBRSC is hosting all the data, but we can also act as a backup data storage here in Abu Dhabi. We have that capability for EMM. In terms of training and outreach, we do have a large number of opportunities for both Emirati students, residents, scientists, and so please get in touch with us. Email address is listed below. We were supposed to host the EMM Mars workshop at NYU Abu Dhabi in March. It got canceled for obvious reasons. But we are very soon starting a space science seminar series for the UAE space sector as well as the international scientific community, and we will be announcing that very soon. So please stay tuned, check out our Center for Space Science webpage. We are also planning a major international Mars conference in fall 2020 because there are a number of missions, Mars missions. Now, I want to finish with this final photo. This was taken just a few days ago. You have scientists working on final fine-tuning on EMM just before it launches in July. And same way at NYU AD, we are fine-tuning our models so that we can work with EMM data. We look forward to collaborating with the EMM science team. Plus, we are looking for more collaborations with the UAE Space Agency and MBRSC. And so thanks a lot for organizing this. And we are very excited for this mission. And yeah, thank you.
Thank you very much, Dimitri, for that insight. And again, showing how universities are getting themselves prepared for the EMM data to come, inshallah. So we are still okay with time. I know Manish, you're probably worried right now, but I think the Q&A in closing, we probably don't need as much time as we anticipated, as we've answered actually close to 100 questions now here. So Manish, the floor is yours.
Thank you so much, Engineer Fahad. Let me share my screen. Good afternoon, everyone. My name is Manish Sharma. I am remote sensing and environment specialist in College of Natural and Health Sciences, Zayed University. I am team representative for the today's meeting on the Emirates Mars Mission Science workshop. In this presentation, I'm going to cover the major research outline, which is already been done on the Mars in the Zayed University, and the information related to the Space and Environmental Chamber. So we are going to set up the Space and Environmental Chamber in Zayed University, which will help us to study the geochemistry, astrobiology, and to learn more about the habitability in the space. One of the application will be to analyze the material from specific environment on Earth that exhibit the similar condition as planets and moons in our solar system. Along with this, we will also carry out the remote sensing study, which will be on-site study, like we will create the similar environment of the Mars or other extraterrestrial planet in the chamber, and we will carry out the science in the chamber. The important features in the chamber will be pressure, gas composition, temperature, control and monitoring, along with the radiation sources. And the temperature will also have the ability to flow the liquids to the chamber and to take the samples in and out without breaking the atmospheric conditions. This will also have the optical and electrical measurement equipments. Best thing is the chamber is being manufactured and fabricated by the local vendors. So in the left, you can see the CAD image prepared for the final Mars chamber or the space chamber. In the right, you can see the chamber along with the source detectors and the components that we're going to couple it with the chamber. So here we will take the help of the Mars Hope probe data to create the environment of the Mars inside the chamber, and we will put different type of the samples to carry out the different spectroscopic analysis or to see the habitability on the surface of the Mars with the help of the different chemistry and the biology fields. Going forward, I would like to share some of the research outline carried out in Zayed University. One of them is geomorphological and compositional analysis of two specific craters on the Mars, which is the Hale and Asimov crater, along with the atmospheric analysis and the study of the recurring slope lineae. Recurring slope lineae, or the RSL, are the dark albedo feature, which is lengthened in the warm season and fade during the winter season. So here is the one of the image you can see. It appears, this is the GIF of the two images. In the one of the image, there is no any RSL appearance, or you can say aqueous feature, whereas in the another image, we can see the RSL appearing in the warm season, and it is incrementally growing. In this project, we mapped more than 941 RSL sites, which are the candidate and the confirmed RSL sites. Confirmed RSL sites are those sites which is favoring the condition of the reoccurrence, lengthening, and the fading property in the particular site, whereas the candidate RSL sites are those sites which is lacking one of the property as mentioned. So in this map, we had used the Mars orbital laser altimeter instrument data in the background, which is telling us the total elevation difference on the Mars surface, and which we used in further project also. So to get the deep examination of the RSL, we carried out this study in the Asimov crater and the Hale crater. Here you can see in the A images, this is the context camera instrument images, which is on board the Mars Reconnaissance Orbiter. So here the red dot and cyan, black and white dots are showing the candidate and the confirmed RSL sites in the particular crater, whereas the B images is showing the overall view of the topographic analysis. So these RSL sites occur normally at the angle, slope degree angle less than 40 degree. So here we can see these are appearing at the crater rim and the central peak. We also carried out the atmospheric factor, which is playing a great role there in the RSL. So here we can see the A image where there is no any RSL appearance, where in the B image there is some tributaries, or we can say RSL is appearing. So we carried out the same atmospheric parameter, which is acting at the same date on which the data is taken through. So we can see in the A image, the temperature is maximum is 159 Kelvin. In the B image, the temperature increased to 262 Kelvin. So the temperature increases. So we can say the ice melting, vapor, and here we also seen the water vapor column is increased by 5 times than the before RSL appearance. Similarly, same case can be observed in the Hale crater also. For this study, we had carried out the study on the high resolution imaging science experiment data on board the Mars Reconnaissance Orbiter, which is the HIRIS. To carry out the detailed surface analysis, we carry the geomorphological study of both the craters. So here we can see the valleys distribution, central crater depression, and other features in the Asimo crater, whereas we divided the geological and the geomorphological unit in the Hell crater and the surface features also. So we concluded this project is like the deliquescence based hypothesis theory, which can be the one of the main source for the RSL appearance. But till now, this is the hyperspectral mineralogical study for which we use the CRISM data, which is having the 20 nanometer spectral resolution and the 500 more than 400 bands, varying from 500 nanometer to 4000 nanometer. So in this, for the color composite images, we had used the RGB band combination, as can be seen in the left hand side, and the formulation to derive those band combinations is mentioned in the right hand side. So by analyzing all these, we had interpreted that the particular crater is majorly composed of the chlorides, hydrated minerals. Water ice is also been observed in some of the images. We concluded this project as the RSL appearing to be supporting the hypothesis of the briny water deliquescence based hypothesis theory. But till now, Mars Planetary Society is having a debatable question that these RSL is an aqueous feature or dry granular flow. Here, Emirates Mars Mission HOP probe will play a great role using the instrument EMIRS, which will provide us the temperature profile, ice, water vapor column. So by taking the data over the RSL sites and by seeing the profile of the water vapor column, we are planning to answer the question, which is debatable from a long time. The second research line is we had carried out the detailed atmospheric analysis and topographic influence in the 9 million square kilometer area on the Mars. So as we can see, the black polygon, which is near the landing site of the Viking 2 and the Mars Science Laboratory. To carry out the topographic analysis, we had derived the 2-dimensional study as well as the 3-dimensional study of the 9 million square kilometer area. We also carried out the slope distribution map, which is telling the 70% of the area is in the range of less than 10.75 degree, which is favorable for the future manned and unmanned mission if we will have any in that particular area. So here is the atmospheric analysis. These are the pressure map, temperature map, water vapor column map, and the wind maps, which is derived from the general circulation model, Mars climate database, which is already been introduced by one of the colleagues from the Mohammed bin Rashid Space Center. So here we derived this pressure map, temperature, and the wind component map and water vapor column for the 3 seasons. As we can see, LS 90 degree, which is the start of northern summer, LS 135, which is the mid of northern summer, and LS 180 degree, which is end of northern summer. Along with this, we had carried out the 24-hour variation in the pressure and temperature, as can be seen in the charts. We also carried out the horizontal wind speed component map as well as the south-north wind component maps. These maps are downloaded from the Mars climate database, which is using the general circulation model numerical simulation on the meteorological fields and validating those results on the basis of available observational database. So these projects is already been selected in LPSE, which is organized by the NASA every year. Going further in the research for the same 9 million square kilometer area, we had carried out the chronological study and the compositional study. Chronological study is carried out to find out the age of the surface. For the surface ages, we carried out the geological map of the 9 million square kilometer area. Then we divide the whole area in the 3 major geological units, which are the Amazonian, Hesperian, and the Noetian unit. And we mapped more than 18,000 craters on these 3 geological units. And based on the crater stress tool, we derived the ages of the geological units. So as we can see, there was a theoretical model introduced by the Hartman and Newcomb in 2001. The crater stress tool, the surface ages is favoring a maximum of that. We had carried out the mineralogical analysis for like one crater from each geological unit, because the CRISM data coverage is not there for the whole area. So here we can see the location. There are 4 locations and the 4 spectra derived through the CRISM datasets, and there are some reference spectra downloaded from the USGS, which is showing the combination of the gypsum, elite, magnocalcite and the ferric oxide. In the university, in Zayed University, we are also working with the physical models for the HEPK-based, for the unmixing of the hyperspectral data for the common source or for the unmixing of the minerals. So for the if we will have some combination in the HOPE probe data, we are also planning to develop a physical model for that to segregate the spectra or the profile for the particular component maps. Here are the list of the publications which is already been published in the Q1 Scopus Index Journal. And these are the list of publication in 2020 till May in the Q1 Scopus Journal, as well as the NASA conference IAC Dubai 2020, and some of the paper and in the preparations. Here, the Emirati students are really interested in doing the projects on the hyperspectral imaging of the unmixing of the data and carrying out a lot of image analysis using the ArcGIS, NV, and the Python programming languages and the softwares. So here is the research team led by the Dr. Professor Faris Havrai, who is the Dean and Professor in College of Natural and Health Sciences, Zayed University. In the end, best wishes to the Emirates Mars mission for the successful launch and throughout the journey of the HOPE probe. We are eagerly waiting for the data to process and to do fruitful research. Thank you so much.
Thank you very much, Manish, for that. You could keep the slide up for a bit so that people who would like to get in contact with you could take down that information right now. We have a question for you, Manish, in terms of how confident are you that you can answer some of the questions about the RSL origin given the resolution that the Emir's observation is going to be providing?
Actually, right now we are having already three benefiting, like the high-res image. We are already having the physical image of the high-res. We are also having the water vapor column, which is already been produced by the Mars Climate Database. In future, we will try to narrow down the Emirates Mars mission resolution for the particular area, and we will try to see the water vapor column up to how much extent it is increasing, and we can answer that question, which is really a great debate in the Mars science community till now.
Yes, it seems so. It's been fantastic. I mean, I would like to thank you, Manish, for that. Obviously, Zayed University have been doing a lot already when it comes to Mars, and now in preparation for everything. So I think, like you said, the EMM data that is going to be coming is going to accelerate your capabilities to be able to drive and do a lot more, and hopefully provide a lot more, answers to science today.
Thank you so much.
Everybody, that concludes our session in terms of the presentations. We still have about 15 minutes. I'm going to try not to take all of that time, but I would really like to thank, of course, Her Excellency Sarah Al Amiri for honoring us and being present today and talking to us about the science overview. I would like to really thank the teams that are working in the background when it comes to the EMM science, in terms of everyone from MBRSC, of course, for all their presentations and providing our audience with the amazing insights and data. We've received comments. I'm receiving them on my WhatsApp and the chats and emails from work colleagues, that they are so happy to have had access to all of this data information that is now going to be shared. The universities from NSSTC, NYU, and ZU, to all the participants, you can see that a lot has already been done and a lot is being done to support this mission. And everybody is excited to see how things move forward. I'd like to thank our attendees. I think, of course, the Emirates Space Innovation Group, which has all the students and professors that we meet with quarterly. This was a special exclusive that we have, and I'm glad to have invited you all here. We have the Global Space Industry Accelerator Group that were here with us. We had the UAE Engineer Society available, and of course, the public that were there asking all these questions. So over 100 questions. I can tell you, I haven't been in a seminar where there have been this many questions asked and answered, which shows the keen interests, and and thank you all for the support of making all of this happen today. From my side as well, just to say that it's been fantastic, the outreach. We're looking to do more of this to make sure to get you the latest information. when it comes to the UAE space sector and everything that's happening. I'd like to give you a quick update as well on what's happening with the EMM. So as I mentioned initially in the beginning, the team are there in Japan. They are healthy. We have a core critical team over there right now. Launch date is still planned for the 15th of July, inshallah. The spacecraft is healthy. All the staff members are healthy. It has been fueled and is getting ready for preparation, to get into the fairing. It has been fueled. So it is really the last, less than 30 days now to go. And we hope to see a successful launch for the UAE to inspire our youth, to inspire the region. There's a lot happening when it comes to the region as well. We have created, under the patronage of His Highness Sheikh Mohammed bin Rashid, the Arab Space Cooperation Group. So there is currently already a project with NSSTC together with MBRSC and other contractors under the H-13 hyperspectral satellite program, where we have contribution from other Arabs, other Arab youths, capable people, scientists, all participating to be a part of that. So I would actually I have nothing more to add except to say thank you to everybody. Abdullah, if there is anything from your side you'd like to add before we... Yes,
Engineer Fahad, we have only the survey.
Yes, that is excellent. So we do have a survey. Abdullah will take you through that. And if you please wouldn't mind, this will help us gauge aspects and also take a look at what we should work on and focus on next. So the first question, I think if you all can see this now on your screens, we have a poll in terms of how was your information about the EMM science prior to the meeting, whether you didn't have any information, this is the first time you're hearing about it, or before joining you had extreme knowledge of everything regarding EMM science. And then the next question is, how useful did you find the workshop was in you gaining information about the EMM science? So hopefully, I can tell you I learned a lot today, and even a lot of colleagues who are actually involved even learned something here. So I'm sure that's going to be a positive outlook. In terms of your excitement, about the EMM mission objectives, if you could answer that. And then do you recommend the session to be recurring as more scientific data is gathered? That way, maybe, we create a spin-off from this and keep continuing to grow the science community. And question 5, how often you feel this kind of session should be conducted? I know with the age of webinars today, and of course, most of us are still stuck at home, or like I like to say, I'm actually living at work now with my family. So how often this kind of session should be conducted so that you can get updates on things that are happening. Overall, your rating, of course, of the workshop is also appreciated. And if you could please answer those, it'll help us improve matters and it'll help us gauge how we can move forward, inshallah. Abdullah, is there anything else from your side?
That's all, Engineer Fahad. We covered all the agenda. Just would like to thank MBA team and especially Her Excellency Sarah Al Amiri, the universities that currently working on the projects.
Miriam, on behalf of the EMM team and MBRSC, would you like to have a few words closing?
I would like to just, on behalf of the team in MBRC, would like to thank you all for participating and for actually arranging this session. It was a really good experience for us, and I believe for the attendees as well. And we look forward to more from here. Thank you for this opportunity.
Thank you, Miriam. Roland, from your side, or Dr. Klaus?
Just to say, yes, thanks for the opportunity to speak to such a large number of people. And I hope that we inspired some students to get in contact with us. We have a lot of opportunities and we're really excited about getting people involved at NSSTC and at UAE University.
Excellent, thank you. Klaus? You're muted, Klaus.
Sorry. From my side, even more feedback on our topics is welcome. So anybody feel free to contact us by mail. Thank you.
Thank you. Dimitra?
Hi, yeah, so this has been a great session. It was good to learn directly from all the people from MBRSC about the mission and yeah, how we can align better with their requirements. And so at NYUAD, we look forward to collaborating more with the UAE Space Agency, with MBRSC, and any students who are watching this, any researchers who want to get in touch with us, please feel free to contact. Yeah, thanks a lot.
Thank you, Dimitra. And Manish, anything from your side from Zayed University?
Zayed University students and the research team really waiting for the Emirates Mars mission for the successful launch and to get the data and to do fruitful research, to answer the unanswered. And this was a great session to learn directly from the Emirates Mars Mission Science team. Thank you so much. And anyone is having any question, contact us. We will feel free to contact us. Thank you so much.
Excellent. Thank you. Well, thank you very much again, everybody, for that wonderful session. I would like to again just thank the teams for making this happen. You know, the AMM team in the background who have helped answer all these questions. I would like to thank Crypto Labs as well for supporting us and hosting this. Abdullah Shahi, thank you so much for all your efforts, and Dr. Fatima as well, all working hard in the background to have made this session a smooth and informative session to all our attendees. So with that, I think I have nothing more to add, and we are closing 5 minutes early, which is fantastic. Allows me time for a breather before my next meeting, inshallah, at 1 o'clock. Thank you all very much, and hope you enjoyed the session. Nice now.
Thank you. Thank you.